Hello, everybody. Welcome back in. My name is Michael. Hope you're having a wonderful day so far. Let's go ahead and jump over to here, rather. All right, let's get this thing started. Hello, Mahan. Welcome in again. It's awesome that you joined so quick. Welcome back. How you doing today? What you working on? What you got on the agenda today for studying? Today, guys, marks the week 6 of Harvard CS50X, so we are well over halfway done with this course. So really, really cool. We've learned a lot so far regarding just general C information. We didn't have any experience programming in C before this course, and now we're able to sort of make our way through some beginner, programming in C. We still have a lot to learn as it is such a wide and broad language, but we have made a lot of progress nonetheless. But we are shifting focus now in the course to other languages, starting with this week in Python. So this is going to be right up our alley. Super, super excited to watch the first half of this lecture. It should be fairly straightforward, as we've been coding in Python since day one, and we've already completed Harvard CS50P. So thank you guys so much for joining me here. If you guys are going to if you guys are here to watch the stream, let me know what you guys are working on in this chat. I'd love to chat with what you guys are working on. You guys have projects? Are you guys studying? Is watching the lecture alongside me here? What you guys doing? How was your days today? Anyways, without further ado, let's go ahead and get started. I'll pause every 15 minutes or so when he kind of allows for it, or and then just to but we're only going to watch half the lecture rather than the full thing in one session. I get too bored after about an hour and a half with just the lectures. I want to break it up. It might help with also just content wise. So let's go ahead and get started. Let me know if the audio is okay.
All right. This is CS50, and this is week 6, wherein we transition away from that programming language called C to another programming language called Python. And whereas a language like C, as you've probably come to appreciate for better or for worse, is like very low level. Like if you want the computer to do something, you have to do almost everything yourself, including asking for memory, giving memory back. Python is actually representative of a type of programming language that's generally referred to as a higher level language, which does a lot of that lower level stuff for you. In other words, you don't have to manage your own memory. You can iterate over things much more quickly than using a traditional for loop as in C. And so in short, a language like Python is just easier and more pleasant, dare say more fun to use. Moreover, it has even more of an ecosystem of libraries being code that other people wrote that you can use. And as we'll see today, it's so much easier to get real work done and really focus on the problems that are of interest to you. What today is also going to be about is teaching yourself a new language. And indeed, the way we're going to approach this lecture and the coming week's problem set and beyond is to give you all of the right tools and techniques via which to learn a new language in the confines of CS50 initially, but after this course on your own. Because even if you don't go off and major in computer science, odds are you'll have some occasion for programming in the future, be it academically, professionally, or for fun. And so odds are a lot of the languages we're talking about today are not going to be nearly as useful in a few years out. But the fundamentals, the ideas underlying them will be the same. And so the goal today is to pick up new ideas and syntax along the way. So recall that where we began was this in week 0, like hello world, everything was so cute and easy to do. It sort of escalated quickly when we got to C, where all of a sudden hello world became a little something like this. But to my point about Python being higher level and just doing more work for you, today in Python, if you want to implement hello world, it's going to be reduced to a single one line. And we'll see this in all sorts of contexts. The catch, though, is that if you want to run Python programs, that process today is going to change a little bit. Recall that in C, we've had this technique for a while now, where you have to make your program, and then you can run it with / whatever the name of the program is. Technically, we revealed that that's short for a longer form command, where clang is the actual compiler. But today, the command is going to be simpler and fewer in quantity, and that this is the command, henceforth, via which we'll run a program in a language like Python. In particular, there's a few things that have changed here. Obviously, the file extension is different. Instead of .c, it's going to be .py or pi for Python. But notice, too, it's only one step instead of two. And that's because, as we'll see, Python is generally described as an interpreted language, whereas C is generally described as a compiled language. And though that's not a characteristic that's intrinsic to the language, just by convention, most everyone in the world, when writing C code, compiles it thereafter from source code to machine code, the zeros and ones that your computer, your CPU, ultimately understands. But Python and other languages like it are a little more user-friendly in that you don't need to write your code, compile your code, run your code. Change your code, compile your code, run your code. You can actually skip the compilation step and just use a program that coincidentally is called Python itself. But whereas Clang, for instance, was a compiler that converted source code to machine code, Python, in this case, is an interpreter, which for now you can think of as just running your code top to bottom, left to right, and looking at each line of code and figuring out what to do with it without actually compiling it to zeros and ones first. So it's a little more user-friendly, half as many steps, and so that, too, is a good thing. Well, let's actually see this in context for a moment in VS Code. Let me go over to the very first program we wrote in C, which was this one here, in a file called hello.c, or in this case, hello0.c. And what I want to do here is create a new program that's the distillation of this in Python. So let me do code of hello.py in this case. Notice that it's opened a second tab as always, but what I'm going to do a bit of today is open two files side by side, just so we can see exactly what's going on. So if I drag this tab over here, you'll see that it'll split the screen in this nice, convenient way. So now I have two files open. But in this file, I'm just going to do print, quote unquote, hello, comma, world, and that's it. Well, what am I next going to do? Well, in order to run this code at write, I don't need to compile it. I just need to interpret it by running a program called Python on a file called hello.py, crossing my fingers as always, and voila, now I have written my first program in Python. So kind of neat insofar as at least it's now one line of code instead of 6. There's no curly braces. There's no includes. There's no int, main, and void. There's just a lot less clutter in there, but the idea is ultimately the same. But what's exciting about Python, and just to kind of motivate why we're introducing a higher level language here on out, you can just get a lot more interesting work done quickly too. So for instance, let me go ahead and do this. Let me go ahead and open up in my own pset5 directory, files that I brought in advance, which was a solution to problem set 5's spell checker, whereby recall that you made a program called speller, but that compiled a file along with it called dictionary.c, which you had to implement the functions within. So if I go ahead and run this program, recall, on maybe one of the bigger files like the Sherlock Holmes text and hit enter, that's going to churn through all of the seeming misspellings therein and tell me that time in total took 1.17 seconds to spell check that whole file. Well, that's pretty darn fast, but consider how many hours, days, week it took to actually implement that spell checker, the contents of dictionary.c. Let me propose that what I'm going to do here is open up a new file called dictionary.py, and I'm going to propose to implement 4 functions, but in Python instead of in C. And those functions are going to be check, load, size, and unload. And let's see how quickly I can churn out problem set 5 using a language like Python instead of C. I'm going to go ahead and open a file called dictionary.py. And in the first line of code, I'm going to give myself a variable called words. And I'm going to set that equal to a function called set, which just like in math gives me a container for a set of values. So no duplicates, for instance. You can think of it like sort of like an array, sort of like a list, but less well-defined in this case. It's just going to be a set of words. Now I'm going to go ahead and define a function in Python called check. Just like in C, it's going to take one word as input. And the way I'm going to implement this check function in Python is quite simply as this: return word.lower in words. All right, that's it for the check function in Python. Now I'm going to go ahead and define another function called load, which just like in C takes a dictionary as input. And then I'm going to implement that as follows: with open dictionary as file, colon, and then below that, words.update file.read.split lines, and that's it for that. And then I'm going to go ahead and return true, capital T. Below that, I'm going to define a size function whose purpose in life is just like in C, to return the size of this here dictionary. So I'm going to return the length of that words variable that I created on my first line. And then down here, I'm going to define, lastly, a function called unload. But as I mentioned earlier, because Python manages your memory for you, you don't need to go and free anything like that. So you know what? I'm just going to say return true, and I'm done. This, then, is problem set 5 written in Python. So bit of a flex, to be fair, because I had the cheat sheet in front of me with all the answers. And it might have taken me, though, a few minutes to actually implement this instead of, indeed, a few hours or, again, a few days. And what's in here should not necessarily be obvious. These are some somewhat cryptic lines of code vis-a-vis what we've been doing in C. But by the end of today, by the end of this week, by the end of the course, after which you've seen more Python, you'll be able to read and understand what's going on here. And in fact, the way I myself wrote this code some time ago was I opened up in one file, dictionary.c, and then I opened up another file, dictionary.py, and I essentially translated the left to the right by Googling as needed the syntax in Python or looking back at my own notes. But that, too, is going to be how we today and this coming week introduce you to this new language by showing you how it is similar to and sometimes different from a language you already know. And so kind of the hard part is done. Now that you know a fairly low-level and challenging language like C, even though it's been just a few weeks, you can really bootstrap yourself to understanding new languages, present and future, by just recognizing
Python.
similarities and patterns. And along the way, there's undoubtedly going to be new features that you encounter in Python and future languages. But no big deal. You're just going to be filling in some gaps in your knowledge at that point instead of starting from scratch. I guess pun intended. Well, let's do one other sort of revelation here. Recall that in problem set 4, you had to implement a few filters, like that of blurring, and maybe you were feeling more comfortable and you did a bit of edge detection. Let me propose that I could do exactly that in some Python code too. So let me go ahead and open up a new file, for instance, called blur.py. Let me go ahead and use a library that comes with Python that we've already installed. It's called the Python image library. So from PIL import image, comma, image filter. Then on my next line, I'm going to create a variable called before. I'm going to set that equal to the return value of a function called image.open. And I'm going to open a file that you've seen before, bridge.bmp. My next line of code, I'm going to create a variable called after to represent the after the filtration of this image, and set that equal to the before variable dot filter, passing in as an argument image filter dot box blur open parenthesis 1. Close parens. And then lastly, I'm going to do after.save, and I'm going to save this file as out.bmp. Now, of course, I'm relying on the fact that there is a file called bridge.bmp. So I'm going to grab a copy of that from problem set 4. And that file is going to be a nice, pretty picture of the Weeks bridge down by the river. And in fact, if I open that up with code of bridge.bmp, this here is the original version of that there bridge. So let's run my 4 lines of blur.py code on this. And just to make it a little more obvious on the screen here, instead of just looking at 1 pixel around every pixel to blur things, I'm going to be a little dramatic and use 10 pixels just to make it even blurrier to appear nicely on the screen. I'm going to go ahead and run Python of blur.py. And when I hit enter, those 4 lines of code will be interpreted, so to speak, top to bottom, left to right. Nothing seems to happen. But if I type ls now, I should see, indeed, a file called out.bmp as well. Let me go ahead and open that, out.bmp. And whereas the before version was this, the after version is now this, in just 4 lines of code. And for those of you who were indeed feeling more comfortable with that same problem set, let me propose to implement the edge detection algorithm that you might recall. And let me create a different file for that. So code of edge.py. And inside of edge.py, I'm going to go ahead and do the same thing as before. From the Python image library, import an image feature and an image filter feature. Then give myself a variable again, before equals image.open, quote unquote, bridge.bmp. Then I've got a variable called after as before, equals before.filter, passing in this time image filter dot find edges, which is a feature that just comes with this library. And then I'm going to go ahead and do after.save. And again, out.bmp. I'm going to very quickly then run Python, the name of the interpreter, on edge.py, which is going to use as input bridge.bmp again, which is the original version. But if I now open up out.bmp and hit enter, instead of looking like this, now, after 4 lines of Python, it looks like this. So if you've been feeling a little frustrated by just how much time, how much energy, how many lines of code it takes to solve problems that ultimately may very well be interesting visually or otherwise, it's now going to get a lot easier to do some of those same features. But, of course, we'll give you the capability to do some more things as well. But before we do that, let's actually take a tour of what some of the features are that we're going to get now with a language called Python, sort of evoking memories of week 1 when we transitioned from Scratch to C. So in the world of Python, there's absolutely functions. You just saw a whole bunch of them. And again, the syntax looks new and different and perhaps a little weird versus C. But over the course of today and this week, everything I just typed will become more familiar. Here's going to be a side-by-side comparison now of Scratch, just like from week 0, to this week in Python, but we'll compare it along the way to some C code as well. So this was, of course, the simplest function we used back in Scratch to just say hello world on the screen. In C, it looked a little something like this, but I've claimed already today in Python, it's going to instead look like this. And just as a little bit of a comparison, what's different? Let's see. Yeah. So there's no semicolon. Amazingly, Python largely gets rid of the semicolon. So when your thought is done, that's it. Python will figure out that it's done. You don't need to terminate your thought with a semicolon. What else is different here?
\n.
Yeah, so \n is missing, which in C we needed to tell the computer to add a new line, so to speak, move the cursor to the next line. Turns out that after years of experience, humans decided that, gosh, we are so often using \n in our print statements. Let's just make it the default instead of vice versa. That does invite the question, well, how do you undo that? But we'll come back to that before long. But indeed, you don't need the \n. The third and final difference, perhaps obvious now, is that it's print instead of printf. That doesn't mean you can't format strings, but the word print is just so much easier to remember. It's a little less arcane. So the Python community decided in their language to call this print instead. And what you're seeing already is the slightest hints of the reality that after years pass and different programmers start using languages, they come up with opinions, what they like, what they don't like. They eventually decide we're going to invent our own language that's better than everything before it. And so what you'll see is that a lot of the frustrations, confusions you might have encountered, you're in good company because some of those now will go away. The catch is, of course, sometimes people will disagree as to what the right outcome is, the right design. And this is why there's actually hundreds, maybe thousands of programming languages in the real world. Thankfully, there's probably only a few dozen that are actually very popular and commonly used in practice. All right, so in the real world, too, we, of course, have libraries. And we saw some of those libraries in the world of C. We're also going to see them in the world of Python, even more powerfully so, like the filtration we just did of images, being able to very quickly implement a spell checker with that, the code that I wrote. In the world of Python, just know that libraries are generally called modules and packages. And there's some slight difference between those two, but for now, modules, packages are just Python terminology for what we already know to be libraries. CS50 has its own library, and in fact, in C, we use this atop any program that we wanted to use getString, getInt, and strings themselves. In Python, there's still going to be a CS50 library, but very brief training wheels that are available, if only to ease the transition from C to Python. But the syntax for using CS50's library henceforth is going to be more simply import CS50. Very similar to what we saw a moment ago with that Python imaging library, Python image library. There's alternative syntax you might see over time where if you only want to import one or specific things, you don't have to import the whole library. You can import from CS50 a specific function or symbol more generally like this. So you'll see two different techniques like that. Well, let's go ahead now and actually build on the program we wrote already by doing something just like we did in week 0, as well as in week 1, where we actually got input from the user. So in Scratch, here was how we prompted the user, what's your name? We got back a so-called return value, and then we joined hello, comma, space, with that their return value. In C, this didn't translate nearly as cleanly. We had to introduce, of course, not only getString for the same function, but we also had to introduce, in the context of printf, these placeholders like %s. For better or for worse, what you're about to see is several different ways to solve the same problem in Python, some of which are a little more similar to Scratch, some of which are a little different from Scratch as well. Don't have to absorb them all from the get-go, but here's how we might do this in Python instead. One, we can declare a variable called answer. We can then set it equal to the return value of getString, which for now is in the CS50 library for Python. You don't need it per se in the real world, but for now, for parity with C, we've given you this getString function. It, like in C, takes an argument, like quote unquote, what's your name, but no semicolon at the end of this line. Second line of code, notice that we're again using print in Python, not printf. We're saying quote unquote hello, comma, space. And then a little weirdly, we're using what looks like the addition operator to add, so to speak, the answer to that end of that phrase. But those familiar or not, what might the plus really represent here? It's not addition in a mathematical sense.
Concatenation.
Yeah. So it's what we would call concatenation, to take one string on the left, one string on the right, and join them. That is, concatenate them together, which is why I need not only the comma grammatically here, but also a space so that we actually have a string that looks the way we intend. So this is one way, then, to implement this here program that we already implemented in Scratch as follows. But there's other ways as well. I can also change this, a little weirdly, to be a comma-separated list of arguments. So it turns out, unlike in C, in Python, if you pass 1, 2, 3, or more arguments to the print function, by default, they will just all be printed, 1, 2, 3, but with a single space in between them. So that's just the way the print function works per its documentation, which we'll see before long. So here I've gotten rid of that space, and I've just said my first argument is hello, comma, and my second argument is answer, and I just leave it to print to effectively concatenate them together on the screen by printing one followed by the other. So that's the second way we might do this in Python. Here's a weird looking third that, for better or for worse, is probably the most common way to do things nowadays, even though it's more of a visual mouthful. So I'm still using the print function, but there's that f again, but in a weird place. It turns out if you want Python's print function to format a string for you by plugging in one or more values, the way you do that is you tell Python, not next to the print function, but to the left of the string itself, that, hey, Python, here comes a format string, aka an f string. And then inside of those quote marks, nicely enough, you can actually use literal placeholders, these curly braces that say put the value of the answer variable there. So it's sort of a new and improved version of printf in C,
love f strings,
which annoyingly always had us using %s, %i, %f, and so forth. Now you just put curly braces and the name of the actual thing you want to plug in to that location. This is called variable interpolation, whereby the variable's value, answer in this case, will be substituted without the curly braces appearing in the final output. So that's then how we might implement exactly that same feature using this thing called a format string. So how might I go about doing this? Well, let me actually go back to VS Code in just a moment here, and let's go ahead and open up my same file called hello.py. So code of hello.py. Let's go ahead and implement this variant thereof. So in hello.py, I previously had just this single line of code. Uh-oh. Yes. What's going on? Oh, it was making noises. Sorry. OK. That was Ian. Thank you, Ian. Oh, thank you, Ian. So here, let me go ahead and open a file called hello1.c, which I brought back from week 1 itself. And let's go ahead and open up hello.py here again. Just so we can see these things side by side, I'm going to drag this one over to top right so we can see hello.c on the left, albeit somewhat cut off, and hello.py on the right. And let's now change hello.py to actually get some user input. So from CS50's library, I'm going to import a function called getString. And then inside of this actual program, I'm going to create a variable called answer. I'm going to set it equal to the return value of getString. I'm going to pass in a prompt like what's your name question mark space, and then close quote and close parenthesis. And then lastly, I'm going to use one of those f strings and print out quote unquote, or rather f quote unquote, hello, comma, answer, close quotes. And it's a little weird now with the f and the quotes and the curly braces and the parentheses, but if you just follow them from inside out, they are all nicely symmetric and balanced. If now in my prompt, I go back down and run python of hello.py, enter, instead of seeing, of course, hello, comma, world immediately, I can type in my name and hit enter, and now I see exactly that. But there's a few things I could do wrong here. For instance, if I forget this here format string and just do quote unquote curly brace answer, and then I go back and run python of hello.py, I'm still going to be prompted for my name, like David, but what's going to go wrong now, intuitively?
Error.
What am I going to see? Yeah. Perfect. Because I haven't told Python that this is a special formatted string with that little f. It's indeed going to print out hello, comma, curly brace answer, just as we see here. So a subtle bug, but one that's very easily fixed with that there f. But there's something else worth noting here. Let me go back over to highlight this code. This varies from C in another way, too. There's indeed no semicolons on lines 3 or 4. But what else is different vis-a-vis the C version here still at left. What's different?
You're not calling a main function just to do something.
How about here? So there's no main, so there's none of this, and there's no curly braces. Yeah, what else? I didn't have to declare the type of the variable. So this, too, for better or for worse, is a feature of Python. We'll see that Python has data types. There are strings, there are ints, there are floats, but you don't need to tell the interpreter what your variables are. Rather, Python, as an interpreter, will just figure it out from context. So if you're assigning a variable called answer to what clearly is going to be a string, the type of that variable answer will be a string. If, though, you used getInt or something similar, the type of that variable might be an int instead. So here, too, a lot of the things that, why doesn't the computer just figure it out, are baked into Python as features. So if I go back over here, after now having implemented this version of hello, we can revisit perhaps something that I glossed over earlier, whereby in Python, the default seems to be to give you a new line at the end of any print statement. But that does kind of invite the question, well, how do you actually get those back, or get rid of that if you indeed do? Well, this gives us a brief opportunity to talk about one piece of jargon in the world of Python and certain other languages, which is that all of these parameters or arguments we've been using for weeks, where you just put a comma-separated list of arguments or values inside of parentheses, when calling a function to give those functions input, those have all this time been called positional parameters, because the order has always mattered. The first thing, the second thing, the third thing influences what the function does with those arguments. But in Python and certain other languages, there's also what we're going to call named parameters, whereby you can actually specify not just a generic comma-separated list of values for which the order matters. You can instead provide the name of a variable and its value, the name of a variable and its value, specifically the name of a parameter and its value as a comma-separated list, the upside of which is that it's a little clearer to you, the reader, you, the programmer, what does what. And it's also not nearly as vulnerable to you just screwing up the order and getting them slightly out of order and constantly having to check the documentation as to what goes in what order. If you recall using fread or fwrite, for instance, which takes a few arguments, I mean, those two are particularly annoying. And even I always forget, like, which comes first. If I could just use the names of those parameters, it might have eliminated some ambiguity. So how can we use in Python named parameters? Well, let's just do a relatively simple example that's actually pretty commonly leveraged, which is this. If I, for whatever reason, let me get rid of my C version now, and in fact, let me simplify this and just go back to printing out in hello.py, hello, comma, world. This, as before, will print out hello, comma, world with a new line. If I want to get rid of this, though, I can do that by consulting the documentation for Python. And in fact, the official documentation for Python lives at this URL, docs.python.org. The upside of this documentation existing is that, unlike C, which doesn't really have an official place to go for documentation other than the manual pages that we, recall, at manual.cs50.io have given you student-friendly versions thereof, like everyone in the world goes to this URL when looking up things for Python officially in its own documentation. For instance, at this particular URL, there is a list of all of the functions that come built into Python itself. And if we poke around further there, there's one indeed called print, which is really the only one I've been using thus far that comes with the language. And in that documentation, you'll see a somewhat cryptic line like this. This is the so-called signature or prototype for the print function. The syntax for this is a little different from what we saw in C. But what I see here in the documentation, if you go to that same URL, is that there's a function called print that takes potentially 1, 2, 3, 4, 5 or more arguments. Five or more arguments or parameters. But what are they? Well, over here is some new syntax. And trust me, this does not mean pointers. There's a star, but nothing to do with memory or star.
This means
or
many objects as
memory
you
or
can
pointers. This just means that there's going to be 0 or more objects that can come as a comma-separated list.
Let's go. We
We've
know
used
our
that feature
Python.
already.
Let's go.
When I printed hello plus name, when I printed hello, comma, name, I got back I passed in 1 or 2 arguments. This just means you can pass in 0 or more just by their position. The rest of these are so-called named parameters, whereby the print function comes with one named parameter called sep for separator, whose default value is a single space, per the quote, unquote. The print function also comes with an end named parameter, whose default value, and here's going to be the answer to that question earlier, is \n. So this is why every line ending from the print function has a \n automatically given. There's something called file. There's something called flush. More on those perhaps another time. But this is why I automatically got a free space when I
don't even know what the file and flush
This
do.
is why I keep seeing my cursor move to the
Does
next
anybody
line.
know what those do?
But the fact that these things have names, SEP and END, means I can use these named parameters if I so choose to override their default arguments. So for instance, if I want to override the separator, I can use quote unquote something else in between words. If I want to override the new line, I can change the \n to something else as well. So if I go back to VS Code here, and for whatever reason, I do want to get rid of that new line ending, I can pass a second argument into print, specify that the name of this parameter is end, and set it equal to not \n, but really anything I want. So just to be dramatic, let's use an exclamation point to sort of excitedly say hello world. And if I now rerun this program as such, now I see hello world, but then my prompt is immediately on the same line. I can get rid of that too if I really want. I can do \n after the exclamation point and rerun this again. And now we're back to the usual. But I do get that exclamation point now for free as default functionality. So it's a little weird because I'm mixing sort of apples and oranges, so to speak, whereby this is positional and this is named. But so long as you put your positional arguments first and any things that have explicit names after those, Python can distinguish one from the other. Questions then on any of this just yet?
All right, we're halfway through the first hour here. That's pretty going. What I told you that the terminal you looked at is really just a combination of 3 files fused together. The terminal I just looked at. All right, who's that? If you guys are here working with me, thank you guys so much for joining. My name is Michael. I'm 26 years old. I've been studying computer science and teaching myself for about 6 months now. We completed Harvard CS50P about 6 months ago with our first introduction to computer science. I graduated college back in 2021 with a degree in human biology and a minor in chemistry. I work as a formulation chemist for a biotech company where I make controls for diagnostics and biological, I make kind of like, serums, plasma, a lot of biological elements and things along those lines. But we've been teaching ourselves Python after my 9-to-5 job for the past, 6 months, but we've been going every day for the past, 3 months or so. It's been really, really fun. I've gotten quite the habit built here and quite the passion for learning this and, picking up. We've been flying through the CS50X course 2025 here. We started at the beginning of the year, January 1st, and we're already over halfway through the course, so we're right on track. We've learned a lot so far, but this Python week is really, really simple because that is the language we actually started with. And so we've been coding in Python live on the channel this entire time. So this week is pretty simple for us so far. Now, obviously, we've had a lot of practice in Python so far, so that can attest to that. But so if you are struggling, with the context so far, just take your time with it. Python's fairly straightforward to wrap your head around. If you're looking for additional resources, I highly suggest that you take the Harvard CS50P course if you're looking for more of a low, not low level in terms of programming, but low level in terms of syntax, just more basic rather than needing a lot of special characters or things like that. Python is great for that because it's fairly straightforward for just the English language and coding via just the English language. And so I personally paired Harvard CS50P with the Python Crash Course book you see behind me. I have a copy of this in my Discord linked below, as well as my personal notes and problems I've solved from this book. This book really helped fill in the gaps left behind in CS50P and really helped to establish a more solidified knowledge in Python to where I was actually building projects on my own. We currently build live projects on this channel every single day. So thank you guys so much for joining me here. But we are going to watch the next, we're only watching the first hour of the Python lecture today. We'll watch the next hour tomorrow. Yeah, we're about halfway through. We're only 30 minutes in, so we got 30 more minutes here. And then we'll wrap up this lecture for today and move on to something else. So let's go ahead and continue here. By default, you write the content to a standard out file or standard output file. Errors typically go to the standard error file or standard error. As per Python documentation for print, the file argument must be an object with a write string method. If it's not present or none, sys.standardout will be used. Okay. So there's just some basic, system file where you write things to that can be, I guess, be read from. Is it separate from the stack frames, or is it similar to those lines? Um, Awesome, Tim. I'm glad you're enjoying it so far. If you guys are enjoying it so far, please, feel free to throw it a thumbs up. It really, really helps, support me and just keep me motivated to keep going. I really enjoy that when you guys, voice your liking for the streams and your support here. So thank you guys truly, truly so much. We've been growing. And if you're here new, consider following along. I stream my live learning every single day. We are currently at 1,287 subs, so maybe by the end of the stream we can hit 1,300, which would be crazy. So thank you guys truly, truly for supporting me every single day. All right, I'll keep reading your comments, Jay, but let's go ahead and keep the lecture going.
Questions? Yeah. A really good question. Can you change the type of a variable once it's there? Can you change, for instance, a string to an integer or maybe vice versa? Short answer, yes. And we're going to trip over that with an example in just a bit. And let me call out one other thing that's worth noting here. In the documentation for Python, and even in your own code, it turns out that you can use single quotes in ways we have not thus far. Recall that in C, double quotes meant it was a string. So typically a phrase, a sentence, a paragraph, whatever. But single quotes in C represented what?
Charge.
So a single character, like that is the definition. In Python, this seems to suggest single characters too, but I clearly just did an exclamation point and then \n, so 2 characters, and that's in fact allowed. In Python, there's no difference between single quotes and double quotes. Stylistically in CS50 and style 50, we'll actually nudge you toward using double quotes just for parity with C, but it is perfectly reasonable to use single quotes instead in Python, but stylistically you should be consistent. Why are they both tolerated? Well, all these weeks you've been holding the darn shift key and then hitting the quote mark to get double quotes. Now you don't have to hit the shift key anymore if you don't want to just speed up your code even more. And that, frankly, is probably part of the motivation for even little syntactic differences like that. All right, how about some other features that we might want to bring into the mix? We've seen use of variables already, like answer. Let's make this a little more. Let's do this side by side with Scratch and with C as well. So in Scratch, this is how we created a variable called counter and initialized it to 0. In C, we achieve that by doing int counter equals 0 semicolon. All right. In Python, we've already seen something reminiscent of this, albeit with strings instead of integers, but probably not a logical leap to assume that this in Python is how you could create a variable called counter, assign it an integer, namely 0. No semicolon, no data type, and this will simply be an int because it's pretty obvious to the interpreter that 0 is an int, not a string. So of course, underneath the hood, this is going to be an int. What else could we do in Scratch? We could change the counter by 1 by incrementing it, adding 1 to it. In C, we saw a few different ways to do this. We can do counter equals counter plus 1, which seems like a paradox. That how could that possibly be? But recall, we do the addition at right. We copy the value from right to left when using the assignment operator. In Python, meanwhile, we would do this. Counter equals counter plus 1. Same exact thing, except for, of course, the semicolon no longer being necessary. But in C, we could also do this. Counter plus equals 1 semicolon. Turns out you can do the exact same thing in Python without the semicolon. But there's one thing you can't do.
The plus.
Who knows why? But what can you probably not do? Yeah, so counter plus plus. If you've been in the habit of using plus plus and minus minus, for better or for worse, Python does not have those. So we're back to the slightly more verbose version here. So we get 2 out of the 3 possibilities. But just a minor difference that will be ingrained over time. Well, what about the actual data types that Python supports? Well, we've used strings already. I just showed some integers there. Python does have its own list of data types, which is actually, at a glance, shorter than C's when it comes to the most primitive ones. In C, we saw at one point pretty much this list, and then we created some of our own. In Python, this list indeed gets a bit shorter, such that we have bools still for true false values. But as you might have glimpsed earlier, it's capital true and capital false, T and F respectively, just because. There are still floats in the world of Python. There are still ints in the world of Python. And there are strings, but they're called strs, STR for short. And there are indeed some other ones as well. But there are no doubles per se. There are no longs. Rather, Python generally uses a bit more memory, so you as the programmer don't need to worry about how many bits are being used, particularly for something like integers. So more on that before long. Good question. Are there no characters? Short answer, correct. There are no characters. There are only strings, which can be single characters and even 0 characters, because, heck, that seems sufficient rather than distinguishing between one or the other. So if you want a character in Python, the best you can do is a string with a single character instead. Now, it turns out in Python there's going to be other features as well. Data structures. So just a week ago, we spent on week 5's material when looking at trees and tries and hash tables and more. Python just gives you those and other data structures built in. No longer do you implement your own spell checker with your own dictionary. You can use, as we did earlier, a set. Turns out there are dictionaries or dict objects that come with Python that you can yourself use. There are tuples, which are like x comma y values, or like latitude comma longitude, so short lists of values. There's actually lists, which are similar in spirit to C's arrays. But recall that the headache of C's arrays as of week 5 was it's not very easy to grow them or shrink them because of all of the darn memory management. Python, if you use a list, essentially gives you a linked list automatically. You don't have to think or use any memory management or pointers at all. And range, we're going to say, just gives you a range of values. If you know you want to count from 1 on up to something else, range is actually a function that can give us some of that same functionality as well. So let's perhaps take some of these out for a spin here. Let me go back to VS Code. Let me close up hello.py. And let's focus on maybe implementing a simple calculator as we did a few weeks ago. In fact, let me go ahead and open up from my distribution code from lecture today, wherein I brought in advance, and these are on CS50's website, a whole bunch of examples from earlier weeks that we already implemented together. So for instance, in week 1, we actually implemented a calculator that prompted the user for 2 ints, x and y, and then simply added them together using printf in this way, with %i as the placeholder and a second argument, which was the sum thereof. Well, if I want to implement this in Python, it's actually going to be pretty similar. So let me also run code of calculator.py. That's going to open a second tab. For the sake of comparison, let me drag this over to the right so we can see these things side by side. And now let me do this. From CS50's library, import the getInt function, which I claim exists in that library. Then let's go ahead and create a variable called x, set it equal to getInt, and pass in a prompt of x colon space, just so the user knows what we're asking for. Then let's do y equals getInt and prompt the user for a y value. And then down here, let's go ahead and print out x plus y. I think it's pretty straightforward as written there. We don't mention the semicolons. We don't mention the data types. But for the most part, the logic is exactly the same. Let me run Python of calculator.py, type in 1, type in 2, and I do get back, in fact, 3. So that calculator seems actually to work. But let's get rid of CS50's library. So just as quickly as we put these training wheels on today, let's take them back off so that at the end of the week, at the end of the course, certainly you're not relying on any of these training wheels anymore. So let me get rid of this line of code at the very top, no longer using getInt. And let's do this using Python's own built-in functionality. So Python itself supports this here function called input, which, similar to getString and getInt and getFloat, takes a prompt as input. So I'm going to say x colon as before. I'm going to go ahead and say input y colon as before. And then I'm just going to print these both out using easy. Python's own input function instead of CS50's getInt. Let's run Python of calculator.py again. Enter. Type in 1. Type in 2. And the answer, of course, should be not 12. So what just happened here? Should still be 3. Yeah. Yeah, so it seems that x and y came back as strings. And so what's happening with the plus operator here is actually being interpreted as concatenation. So I'm really saying not 12 per se, but 1, 2 joined together. Because the variable that apparently, the return value that comes back from Python's own input function appears to be a string That is a stir by
Convert it
default.
to an
Now,
integer.
there are ways to fix this in Python. And in C, recall that we were able to cast some values from one to another, like ints to chars and back and forth. It's not quite as easy as that in Python, because technically a string, as we know underneath the hood, has one or more characters. Maybe there's a \0 somewhere in there. Who knows how Python is doing it? But there is a function in Python called int, which takes as input a string, and it will do its best to convert that string to the actual int that resembles it. So if it's quote unquote 1, it's going to give me the actual int known as 1, and so forth. So let me do that here as well as here. Let me again run python of calculator.py, enter, 1 again, 2 again, and this time 1 plus 2 equals 3. So similar in spirit, but now I just need a new tool in my toolkit, this int function, which does that conversion for me. Now, what actually is in this library? CS50's own that you may or may not want to use. So in C, we had these functions, as well as some other stuff, including the actual definition of string. In Python, there are indeed strings that come with the language. They're simply called strs, str. In CS50's library for Python, though, we kept it simpler and consistent with Python, the language itself. So CS50's library for Python has getString, it has getInt, it has getFloat. These, we'll see, are still useful, because just like in C, recall that if the user types in like cat or dog, when you're actually asking them for an integer, our functions prompt the user again and again and again. So these functions will do that as well. We'll soon see that the input function in Python is quite similar to getString, but it's not as tolerant of invalid input, like cat or dog. If you're actually trying to get an int or a float, you're just going to see a scary error message instead on the screen, which we'll come back to before long. But this is to say the library is there to get you started, but not strictly necessary ultimately. But if you want to use those functions, you can do as before, from CS50, import the name of the function. And you can do this 3 times. If for whatever reason in a program you're using all 3 of these, you can just separate them by commas in this way and import all 3 of them here at once. Or, as you might recall earlier, you can just import the name of the library. So something like import CS50, though the syntax thereafter changes a bit. Before we forge ahead to now conditionals, just comparing something side by side, and then we'll build up some more interesting programs. Questions? For the most part, it's just syntactic differences and not really fundamentally different intellectual ideas under the hood just yet. So here we are with conditionals. In Scratch, if you wanted to compare x and y as variables and say conditionally x is less than y, we converted that to C as follows. The curly braces are about to go away. The semicolon's about to go away. And there's going to be one new piece of syntax here. In Python, the same idea looks like this. What is the one piece of syntax that did get added, though, in this case? Feel free to shout it out. There's a colon suddenly, which we did not have in C. It turns out in Python, though, this is both a plus and a minus depending on your religion when it comes to white space in programs. So in C, if you were not in the habit of clicking style 50 and letting it guide you toward better formatted code, frankly, you could just left align everything in your C programs. And even though it would be a mess to read, difficult to grade, it would still work. It would still be correct, but just stylistically bad. In Python, it seems that humans over the years were just so darn frustrated by students and presumably colleagues alike formatting their code poorly that in Python, indentation matters. So if you want to execute print conditional on x being less than y, you can't just put print right below if and expect the reader and the interpreter to figure things out. You must indent by convention 4 spaces instead. You can override that and you can adopt different paradigms within your own company or school, but 4 is what style 50 would now expect. So this is to say the colon means execute conditionally everything that's indented below that as though there were curly braces instead. All right, how about something else in Scratch? If you wanted to do an if-else, it looked like this. In C, it looked like this, which is identical except for the else block here. In Python, you can probably predict how this is going to get a little more succinct. No more semicolons, no more curly braces, no more \n's for that matter, but a colon here and a colon here. And again, indentation matters and must be consistent. 4 spaces in this case for both. Finally, if, else we did in Scratch. You can do that same thing in C, almost identical, except that we've got this else if. This is the only one that's weird, and even I forget how to spell this all of the time. In Python, the semicolons are about to go away. The new line is going to go away. The curly braces are going to go away. And we're going to misspell else if as such. So it's elif in Python, colon, which is how you would implement if, else for a conditional like this. Some languages, very confusingly, use else if, where E-L-S-I-F, but no E. And probably shouldn't have even said that, because now you'll be as confused as I have been for years. But let's move on to what we can actually do now with these here strings. So we know we can use these conditionals in this way. Let's go ahead now and revisit some programs from C, but this time using some new syntax and features. So let me go back to here, VS Code. Let me open up in one window here. How about compare3.c? So this was from today's distribution code, a file called compare3.c, which we looked at some time ago. And what this program did, quite simply, is exactly what we just saw on the screen, but with a full-fledged main function and the header files and the like. But all this program does is tell us whether x is less than y or not. All right, how can we go about implementing this in Python? Pretty straightforward. Let me open my terminal. Let me do code of compare.py for this version. Let me drag it over to the right so I can see these things side by side and hide my terminal again. Let's go ahead and import from CS50 the getInt function, just to make our lives a little easier for now. Let's use x equals getInt and prompt the user for what's x question mark, just like I did at left. Let's do y equals getInt, passing in what's y question mark, just like at left. Then let's just do if x is less than y, colon, enter. And notice VS Code is not only smart enough, but deliberately configured by us to know something about Python. So it automatically indented for me, just like C very often has too. Let's print out x is less than y, quote unquote. If x greater than y, colon, then let's print out x is greater than y, close quote. Else, colon, print out x is equal to y. So nothing different versus the slides. But you can kind of see visually just how much more compact the code is, like 11 actual lines instead of 21. So it's just eliminating a lot of distraction and clutter and tightening things up, if nothing else. Let's go ahead and run Python of compare.py, enter. Let's type in 1, type in 2, and let me just wave my hand at the reality that I'm pretty sure the code is correct and would work correctly if we typed in 2 and 1, or 1 and 1, 2 and 2, and so forth. So this is to say that comparing integers in Python logically works exactly the same way as in C. But things, recall, in Python got a little weirder when we actually tried comparing, say, strings instead. And recall that when we compared strings in Python, we had to solve a problem we encountered. The very first time we compared two strings in C, S and T, as I think I called them weeks ago, they were never the same, according to my first version of my code. Why? Why is it harder to compare strings in C? Exactly. So recall from week 4, where we really looked underneath the hood and we realized that, oh, a string is really a char star, which is the address of the first character in the string. So whenever you compare two strings with equals equals in C, you're really comparing the memory addresses, and those probably are not going to be the same. So even if the strings look the same, they're always different. That was a pain in the neck. We had to add in the string library and the str compare function, strcomp, strcmp. It was just a lot of work to do something so darn common. It is super common to want to compare strings. In Python, wonderfully, let me close the int-based version from C here. Let me propose here that in Python, if you want to manipulate strings, you could use CS50's own getString function, but I don't even need that. I can use the input function, as we saw earlier. So if I want to prompt the user for s equals the return value of input and just prompt them for a string like s, t equals the input function, prompt them for a string called t. In Python, wonderfully, it works the way you would hope. If s equals t, then print out, quote unquote, same, else print out, quote unquote, different. So here again, it just works the way you would hope, and you don't have to pull out your textbook or your old examples to figure out how to do something relatively straightforward conceptually, as comparing two strings. Let's do one other example that evokes a past example as well. Let me open up a program that in week 1 we called agree.c. So at left, here was a program that we wrote several weeks ago now that used the CS50 library, the standard IO library. It used the getChar function to ask the user, do you agree with some terms and conditions or whatever. And then we used this syntax, which was very new in week 1, because not only were we using equals equals, we used the vertical bars, which meant what, logically? So so we used or to detect if someone typed in uppercase or lowercase for either y, or big Y, little y, or big N, little n as well. So in Python, let's do this instead. Code of agree.py. I'll hide my terminal window, but I'll drag this here over at left. And in the Python version of this, turns out I can do something similar as follows. Let's do s equals input and prompt the user, do you agree, question mark. Then let's say if s equals quote unquote y, or s equals quote unquote little y, then print out quote unquote agreed, just like in the C version. If s equals capital N, or s equals lowercase n, then print out not agreed, just like in the C version. And here again, we're sort of seeing just how much this condenses our code. It's working logically the same, but what are some of the differences visually? Well, there's no curly braces, there's no semicolons, there's new lines, but what is there? Like, this is why Python 2 is considered more user-friendly. If you want to express the idea of or, we'll like literally write or instead of vertical bars and double ampersands and the like. So I'm using or here as well as or here. Notice there's no parentheses either around these conditionals. So we didn't see those on the slides. We don't see them here. What Python does with parentheses is that if you don't need them logically to combine Boolean expressions, just don't use them at all. You could use them here and here, and here and here. But if it's not necessary, why bother further cluttering your code? You simply do not need to do it. But let's see if there's a way to improve this. Let me first run this and make sure it works as it's intended.
It's going to lower it, everything, or it's going to upper it?
Do I agree? An emphatic yes. OK, let's do a lowercase n. And agreed and not agreed are indeed the answers I get back. But this feels a little redundant, I would say. Notice that my code here is really just asking the same question twice, albeit for lowercase. And it's asking the same question twice here, albeit for lowercase, for the n as well. Well, it turns out in Python, I can actually tighten this up. Let me get rid of my C version and focus on this one. And let me go ahead and condense this further as follows. If s is in the following list of values, quote unquote y, quote unquote little y, colon.
In a list?
And then down here, I'm going to do the exact same thing logically. If s is in this list of comma separated values, capital N, lowercase n, this now would achieve the same results. It's a little tighter because I'm not using or. I'm not using equals 4 times. I'm using it not at all, in fact. I'm using a new keyword, which in Python exists. In, as a preposition, is a Python keyword. Does not exist in C. But this here would be a little tighter as well. So let me go ahead and run python of agree.py. Enter. Do I agree? Capital Y. It still works. Or if I do lowercase y, it still works. But this isn't as featureful as would be ideal, because what if the user types in, for instance, an emphatic yes in all caps? Well, now it just ignores me altogether. Now, you could go in and, of course, address that. I could do capital yes and lowercase yes. But wait a minute. What if they just capitalize the first letter? So I should really have Y-E-S. And then, well, what if their like caps lock is not working as intended? And maybe we do something like this. And now we got to do this. I mean, these are all like spelled the same, even if they're miscapitalized. So this just feels like it's becoming a mess pretty quickly. So logically, whether it's in C now or in Python, what would ideally be a better logical solution to this than enumerating all possible values that we care about? Yeah. Yeah, why don't we just change the user's input to lowercase, or equivalently, just change it to uppercase to canonicalize it, like make it the way I expect it to be, and then compare it against a much shorter finite list of values. So how do we do this? Well, in C, in the C-type library, we had a toLower function, which was handy, and we had toUpper. But in Python, what's nice is that Python actually has not only strs, or strings, as first-class objects that come with the language itself. Python itself as a language is known as an object-oriented language, and it has other features as well. And some of you in high school, if you ever studied Java or the like, you might already know about object-oriented programming, otherwise known as OOP. And what this is sort of referring to is a new and improved version of C structs. Recall that in C we had structs, whereby we could create our own data types for like persons or nodes, for instance, by creating our own data types that have one or more other values inside of them. Well, what C doesn't offer you, at least not easily, is to associate functionality with those structures as well. For instance, for a person object, wouldn't it be nice if there were a function, especially if running the code on your phone, that was a call function that would just automatically call that person, or an email function that would just automatically email that person if we're keeping track of their email address as well? Well, you could implement a call function and pass the person in as input. You could implement a call function and pass the person in as input, and then it would work. But wouldn't it be nice to sort of associate more tightly and encapsulate related functionality, just like we've been encapsulating related data? And this is what object-oriented programming allows you to do. Instead of having what are called structs in C, you have what are called objects in Python and certain other languages as well. And those objects are typically defined what's called a class, when a class is really just like a blueprint or a template out of which multiple objects can be made. And specifically, in the context of this here example, we could consult the documentation for the functions that come with the stir object, the string object. And technically, whenever functionality is associated with a specific data type, it's encapsulated inside. It's still a function, but you technically call it a method in that case instead. So a function is what all we've been discussing in C and in Scratch. In Python, you still have functions, but if those functions are associated with a data type tucked away inside of them, then they're just also called methods. It's a minor nuance there. And among the functions, among the methods rather, that comes with stirs or strings is a little something called lower. And there's different ways to go about doing this. So let me go ahead and, one, simplify this list to just be the list of values that I actually care about. So let's suppose that I want to support quote unquote y and quote unquote yes, but I don't care about the capitalization thereof. So I could do this. I could take the s variable, and I could actually let's do this. I can create another variable, t, set it equal to s dot lower, open paren, close paren. So notice the dot operator, just like in C, goes inside of the object. Same thing in Python. But here, I'm not going inside of it to get the person's name or their number or their email address. I'm going inside of it to call a method that just comes with that type of value. So in C, just to be super clear, we would have done to lower and pass in s. Python, in an object-oriented programming more generally, just kind of flips that paradigm and says, start with the variable in question and call its own lowercase method as such. And now if I change this code to T down here and here, and I go in here and I search for lowercase n or lowercase no, and I run this version of agree.py, enter, I can now type in y for yes, capitalized, y for yes, lowercase, y-e-s, all capitalized for yes, y lowercase, capital S, like that, any of those variants that exist, and I only have to enumerate canonical versions thereof. Even better, I can kind of tighten this up further. I don't really need a t variable. In fact, I could just do s equals s dot lower and change the value of s to be the lowercase version thereof. What's nice about Python 2 is you can chain method calls together. So if you know that input as a function already returns a string, you don't need to tuck it in a variable before you call that string's lower method, and you can just chain them together in this way. And you could do this sort of again and again. This is not a real function, but you could keep chaining these things together one or more times. At some point, it's going to look stupid because it's just going to be too long of a line of code, and then we get into discussions of style. But for now, having two function calls like this is pretty reasonable, I would argue. And so this just tightens up the code further. All right, so that is perhaps the newest feature that we've now seen of Python, this notion of methods, which derives from this feature of object-oriented programming. But any questions before we take a quick tour of a few other features as well? No? OK, how about a couple more examples, then introduce some loops, and we'll skate our way toward some snacks in just a few. All right. So,
all right, we will pause it right there. That's where we'll pause the lecture. So we'll watch the second half tomorrow at the beginning of the stream, but we'll watch just the first half today. I knew that Python was going to be a little bit of a snoozer because we're already pretty solid on all this, but functions that are applied to an object itself if applicable, changing the state in place. Right. Okay. Sweet. All right, that was lecture part 1 of CS50X week 6, lecture 6 on Python. Super, super informative for those that maybe are lacking on Python skills. I'm going to be honest, I didn't really have to pay much attention during that. I kind of just chimed in and focused back up when he kind of mentioned that he was going to start programming so I could write it down for the notes, but it was kind of a snoozer, like I said. But we will watch the second half of this lecture tomorrow at the beginning of the stream. Sweet. All right, let me go ahead and stop my recording of that. Underrated tip, watch that posture. Yeah, I need to get myself a new chair for sure. I sit in all sorts of funky ways. I was hoping that if the stream ever got to a point where it made a little bit of money, then the first thing I would buy would be a new chair. But it's kind of funny. All right. Thank you, Joe. I'll have to check that out. I'll have to check that out. All right, you guys, let's go ahead and shift focus a little bit here because we were talking about Python right now. It might be fun to go ahead and take a stab at the Small Business Manager project and work on, we're almost done with the chapter 8 though, so if we can just try to get a little bit further, let's just read. I know we just did learning, guys, but let's just read this 9.4 section because then we're on 9.5 and that's the last section of the chapter, I believe. Yeah, so we're almost done with the priority queue chapter. So I know we just did an hour of learning, but the learning never stops. Got to keep going. Let's just bust out chapter 9 or 9.4 section 9.4 here. 4 or 5 pages, and then we will move on to some live programming in our Small Business Manager because I added in some features yesterday. I coded yesterday off stream on the Small Business Manager while watching The Crown on Netflix. You haven't seen anybody watch The Crown? I really like kind of those old school British shows. I don't You call me cringe or whatever, I don't care. For some reason, I'm just like hooked to the TV when they come on. Like no other show really does that to me besides like these old time British dramas. Like they just get me somehow. I don't know. Maybe in a past life I was like a stable boy and but back in the main, the homeland of Britain, maybe I was a stable boy or something, but sorry if that was a terrible British accent. Anyways, but I can't get enough of those shows. So I was watching that show last night while I was programming, and so I want to show you guys some of the features that we added onto the Small Business Manager. I fixed some bugs, kind of tightened things up, and I'll kind of help explain things in there as well. So, but I programmed yesterday live, just not live, off stream while watching that show from 11 to like 1:30 in the morning. So I did a solid 2.5 hours of just straight programming, adding stuff, debugging, fixing things. I I changed around. I fixed the bug to where if you edit items after they're edit expenses rather, and reduce the expense cost, right? Like there's a typo or something, or an adjusted price later on for a dispute or a rebate. You have to go back in there and re-update the expense to a lower amount. Right before, it wouldn't actually reduce the total the expenses operating for the annual operating expenses or annual gross expenses. Sorry. So now I have it actually reducing that value and pulling that information as well. And then I just kind of cleaned up some stuff with the displaying of the items, and then editing the individual items as well. So we do need to add that same feature to the items for the sold transact items. If an item is sold, right, I have to have that updated as well. Yeah, 11. Yeah, I was up pretty late last night programming code. I was watching The Crown, and I had the electric blanket on and was just programming. About 11 to 1 at 1:30 a.m. And I had to get up for work at like 7, so I'm running on fumes here, guys. So make sure to hit a thumbs up. I really really appreciate it. I've been putting in a lot of hard work under the streams. Just showing up day after day is enough work on its own after my job and all the side stuff I do with just putting together the Discord and all that stuff. I know I got a long ways to go, but thank you guys so much. Yeah, Nugs, I was just like, I don't know what it is about programming specifically, but I've never experienced something, maybe besides like playing guitar, where I can sit down and start, and then once you kind of get into a flow, like I've never gotten into like a flow state like I have when programming. Like it'll just suddenly, all of a sudden, you'll be working and you'll just get really, really into it. Really, you get this like when you fix something, you get this little kick. When you fix another thing, you get this another little hit. It's just like this. I don't know. Like programming is kind of like a drug, and it really sucked me in. And then next thing you know, 2.5, 3 hours have just gone by out of nowhere. Like on these streams, like I'll do some live programming, and then on my small business manager, I'll look down, and 2 hours of the stream is already gone, and I was like, what? Like that isn't. This is how are we already? So I sometimes get caught up in it. Hey Zanab, welcome. I appreciate you coming in. Eclipse, thank you for let's. You'll have to show me. We'll have to do a British accent contest. Also, guys, I thought of the idea. Let me know. I wanted to bring this back up for some people that maybe weren't in the other stream. I wanted to implement a kind of giving back to you guys for obviously supporting me, supporting yourselves, coming into the streams, obviously, working on yourselves, improving your own programming. I wanted to give back to you guys as much as I could. And so I was thinking it might be fun every stream or every other stream or something to open a Pokemon card pack and then collect those cards and give them away at the end of a set period of time to the viewers. So I'll kind of like file them into a binder and then give them away to a select viewer or a few viewers a page or something. So if that sounds like something that you're interested in, then let me know. I think it would be fun just to give back and help, at a midway point through the stream, just crack open a Pokemon card pack, see what we get, and give it away. Programming is addicting for me. Yeah, me too. I'm sucked in here, man. 6 months going here, and we not stopping anytime soon. Yeah. My girlfriend often tells me, she's like, tries to remind me like priorities, and I'm programming like 4 or 5 hours straight. She's like, you gotta take a break, gotta do something. I'm like, yeah, I know. I've been doing it every year for about a day. Oh, hold on. It is two. Been doing it every year for about a decade. Every year. What do you mean every? What have you been doing every year? Every month and every day for 6 years. Nugs. Is Nugs famous? Nugs, are you famous? All right. All right, cool. So let's go ahead and let's close that up. And then let me go ahead and open up the DSA Python here. Okay, so we're on 9.4 here, sorting with the priority queue. Sorting with a priority queue, right? Okay, so we'll just read it. We'll get through this section and then we'll move on to some live coding. How about, guys? We probably won't solve maybe we might take a stab at a leak code problem. I'm just not really in the mood for you computing a lot of brain power right now. Anyways, I'm pretty tired. In defining, so sorting with a priority queue. In defining the priority queue ADT, we noted that any type of object can be used as a key. Hold on, I gotta take out my headphones to read. I can't hear myself read. We define any use as a key, right? But that any pair of keys must be comparable to each other, and that the set of keys can be naturally ordered. In Python, it's common to rely on the less than operator to define such an order, in which case we follow the properties must be satisfied. Irreflexive property. K is not less than K. What? Irreflexive property. Transitive property. If K1 is less than K2 and K2 is less than K3, then K1 is less than K3. Formally, such a relationship defines what is known as a strict weak order. So we have, let's go here, go irreflexive property. And then let's do transitive property. Okay, so let's go, can you please explain the irreflex property? Of course, the irreflexive property is a characteristic of a relation on a set where no element is related to itself. In similar terms, if a relation R on a set S is irreflexive, then for every element A within the set, the pair AA does not exist, is not related. The pair AA is not related. Wait, is not in R? Relation R on a set. Can you break down some of the symbols? Of course, here's a breakdown of the symbols. Set S equals 1, 2, 3. Yep. This means that S is a collection of elements in the case of numbers 1, 2, 3. The curly braces. Gotcha. Relation R. A relation is a collection of ordered pairs A and B that show how elements are in the set are related. Example, R 1, 2, and 2, 3 means that 1 is related to 2 and 2 is related to 3. AA not R, right? Not in R. The symbol not in. So it means that the pair AA where an element is related, so it is not part of the relation R. Tech says, oh, hold on. We got some other comments here. As long as you're fluent. Operating system was notoriously the hardest course in my school in terms of workload more than conceptual complexity. Any specific reasons you're using VS Code for taking notes is very clunky with images and not exactly good looking. Try Bare Notes Markdown writing app. It allows exporting in a variety of formats. I mean, yeah, we are using the Markdown formatting here. So if I just shift V here, it'll clean it up really nicely, right? So it's Markdown. It's just this is the editing format, right? I mean, it looks pretty good. I like this pretty good. But yeah, people have been suggestion. I like NeoVim for taking notes. Yeah, people have been suggesting a lot of different things like Jupyter. There's so many different resources out there. It's just is like it's kind of intimidating to branch out. Yes, let's see a real example. So a real life example of an irreflexive relation is taller than is a real irreflexive relation. No person is taller than themselves. If S is a group of people, Alice, Bob, Carol, the relation R consists of pairs like Alice, Bob, meaning Alice is taller than Bob. Irreflexive rule, there won't be a pair Alice, Alice because Alice can't be taller than herself. Okay. So then we'll say, can you provide me a simple def in given that example? A relation is irreflexive if nothing in the set is related to itself. A relation is irreflexive if nothing in the set is related to itself. we'll say here, example, right? Quote is taller than, right? No one can be taller than themselves. Right? Cool. So we'll say like if you have a set of values here, we'll say, Mike. We'll say who we got here. We got Nugs. How tall are you, Nugs? Somebody give me a height. Nugs. We got Josh. We got Mike. Michael, rather. Keep it consistent. So in this set, Nugs is shorter than, or 5'11", okay. 180 centimeters. In this example, Josh is taller than Nugs. Michael is taller than Josh, but no one is taller than themselves. Like that. I put myself at the end there. Sorry, guys. Sorry to you short kings out there. I put myself at the end on purpose. The perfect, you're spot on. Is taller than be taller than themselves. Okay. Sweet. Anybody? I will give you my height. I'm kind of in between on a good day and a bad day. 6 foot and 6'1". 6'1" if I'm like not slouching, but I usually slouch. So about 6 foot is my height. My dad is 6'2". I was hoping to get 6'2", but I'm shorter than my old man. All right, cool. Next up, transitive property. Transitive, okay, so if, so then can you give me a simple def for the transitive property? Transitive, sorry. A relative relation is transitive whenever one thing is related to a second thing and the second thing is related to a third thing. Then the first thing is also related to. Okay, so a relation is transitive if whenever one thing is related to a second and the second is related to a third, then the first is also related to the third, right? So here we have example is taller than, right? Which will go height can be ordered, right? So this will say if you have a set, you have the same set here, right? Josh is taller than Nugs, Michael is taller than Josh. Thus, Michael is taller than, sorry Nugs, my bad. Didn't mean to pick on you here. And Michael is taller than. Okay, like that. That's perfect and clear. A relation is transitive if, whenever one thing is related to a second, the second thing is related to the first. Taller than a height can be ordered. Right. Height can be ordered. So if you have a set of nugs, there we go. Okay. Sweet. Now we're moving on. Formally, such a relationship defines what is known as a strict weak order, right? A strict weak order, as it allows for keys to be considered equal to each other, but the broader equivalence classes are totally ordered, as they can be equally arranged from smallest to largest due to the transitive property. Okay, so this is just saying that you can have heights of the same, but they'll still have order, within that, kind of. So, strict weak order. Strict weak order is a type of relation that satisfies these key properties. Think of strict weak order like sorting people by height. You can say one is taller than the other, but some might be incomparable because their height isn't known. Want an even simpler explanation? Yes. A way of comparing things where no one compares themselves. A is related to B, intransitive, no reversing. Some items may be unrelated. So strict weak order. Anybody have a good definition? Can you give me a simple def? A way to compare things where no item is compared to itself. The order is consistent, and not everything has to be comparable. Okay, we'll just take this then. I like that. Alright, so compared to itself, the order is consistent if A is greater than B, B is greater than C, then A is greater than C. Not everything has to be comparable. Sorting people by height, some people's heights may be unknown. Right, so this can be our example. We'll just take this right from here. How about? Sorting people by height. Okay. As our first application of priority queues, we demonstrate how they can be used to sort a collection C of comparable elements. That is, we can produce a sequence of elements of C in increasing order, or at least in non-decreasing order if there are duplicates. The algorithm is quite simple. We insert all elements into an initially empty priority queue, and then we repeatedly call remove min to retrieve the elements in non-decreasing order. An implementation of this algorithm is given in code fragment 9.7, assuming that C is a positional list. We use the original element of the collection as both a key and value in calling p.add element element. Okay, so we have priority queue sort on a collection. So n is equal to the length. We have an empty priority queue for j in the range of n, the length of the collection. We're going to delete, call collection.delete collection first, which will return back that element. And then we'll add element. For range n, and then we have another loop, not nested, just another linear loop that says for j in the range of n. I mean, we're not even, so we're just going over indexes, but we're not calling j anywhere either. Or okay, so remove min and then add it to the last. An implementation of the priority queue sort function, assuming an appropriate implementation. Note that each element of the list input list C serves as its own key in the priority queue P. With minor modifications to this code, we can provide more general support, sorting elements according to an order or according to an ordering other than the default. For example, when working with strings, the less than operator defines a lexicographic ordering, uh, which is an extension of the alphabetical ordering to Unicode. For example, we have that quote 12 is less than quote 4 because the order of the first character of each string. Just as quote apple is less than quote banana, suppose that we have an application in which we have a list of strings that are known to represent integral values, quote 12, and our goal is to store the strings according to those integral values. In Python, the standard approach for customizing the order of sorting algorithm is to provide as an optional parameter to the sorting function an object that it is itself a one parameter function that computes the key for a given element. See section 1.5 and 110 for discussion on this approach with the max. For example, with a list of numeric strings, we might wish to use the int string as a key for a string s in the list. In this case, the constructor for the int class can serve as the one parameter function for computing a key. In the way the quote 4 will be ordered before the quote 12 because its key int 4 is less than int 12. We leave it as an exercise. Okay, so it's just saying, I gotcha. So if the keys, you just have to convert them to do the comparison if they're within quotes. Selection sort and insertion sort. Our priority queue sort function works correctly given any valid implementation of the priority queue class. However, the running time of the algorithm depends on the running times of the operations add and remove min for the given priority queue class. We next discuss a choice of priority queue implementations that in effect cause the PQ sort computation to behave as one of the several classic sorting algorithms. Selection sort. If we implement P with an unordered list, then phase 1 of the PQ sort takes O of n time, for we can add each element in constant time. In phase 2, the running time of each remove in operation is proportional to the size of P. Thus, the bottleneck computation is repeated. This is the repeated selection of the minimum element in phase 2. For this reason, the algorithm is better known as the selection sort. As noted below, the bottleneck is in phase 2, where we repeatedly remove an element with the smallest key from the priority queue. The size of P starts at n and incrementally decreases with each remove min until it becomes 0. Thus, the first operation takes O of n. The second operation takes O n minus 1, and so on. Therefore, the total top operation time is O of n squared. Phase 2 takes O of n squared. Thus, phase 2 takes O of n squared, as does the entire selection sort algorithm. Right, so here's an example of this is our input of collection. We have an empty priority queue. Phase 1 will pop off values and insert them into our priority queue. Phase 2 gives you builds you a tree, a selection sort. Okay. So you start with the minimum element and then continually increase from there and build n minus 1. Okay. Insertion sort. If we implement the priority queue P using a sorted list, then we improve the running time to O of n for each remove operation on P now takes O of 1 time. Unfortunately, phase 1 becomes the bottleneck for the running time since in the worst case, each add operation takes the time proportional to the current size of the position of the right. This sorting algorithm is better known as insertion sort. In fact, our implementation for adding an element to a priority queue is almost identical to a step of insertion sort as presented in section 7.5. The worst case running time of phase 1 of insertion sort is O of n squared. The best case is O of n. Okay, then heap sort. As we have previously observed, Realizing a priority queue with a heap has advantage that all the methods in the priority queue ADT run in logarithmic time or better. Hence, this realization is suitable for applications where fast running times are sought for all the priority queue methods. Therefore, let us again consider the priority queue sort scheme, PQ sort scheme, this time using a heap-based implementation of the priority queue. During phase 1, the ith add operation takes O log I time, since the heap has I entries after the operation is performed. Therefore, this phase takes O log n time. It could be improved to O of n with the bottom-up heap construction described in section 936. During the second phase of the PQ sort, the jth remove operation runs in O log n minus j plus 1, since the heap has n minus 1 j plus 1 entries at the time of the operation is performed. Summing all over all j, this takes n log n time. So the entire priority queue sort runs in n log n time when we use a heap to implement the priority queue. This sorting algorithm is better known as heap sort, and its performance is summarized in the following proposition. The heap sort algorithm sorts a collection C of n elements in O n log n time, assuming two elements of C can be compared in O of 1 time. Let us stress that the O n log n running time for heap sort is considerably better than the O of n squared running time for selection and insertion sort. Implementing heap sort in place. In the collection C, if the collection C to be sorted is implemented by means of an array-based sequence, most notably a Python list, we can speed up heap sort and reduce its space requirement by a constant factor using a portion of the list to itself to store the heap, thus avoiding the use of an auxiliary heap data structure. This is accomplished by modifying the algorithm as follows. We redefine the heap operation to be a maximum-oriented heap, which means position keys being at least as large as its children. This can be done by recording the algorithm or by recoding the algorithm or by adjusting the notion of keys to be negatively oriented. At the time of insertion, at the time during the execution of the algorithm, we use the left portion of the collection up to a certain index I minus 1 to store the entries of the heap, and the right portion of the collection from index I to n minus 1 to store the elements of the sequence. Thus, the first I elements of the collection, 0 indices 0 all the way to I minus 1, provide the array list representation of the heap. In the first phase of the algorithm, we start with an empty heap and move the boundary between the heap and the sequence from left to right, one step at a time. For step I, for I equals 1 all the way to n, we expand the heap by adding the element at index I minus 1. Yeah, so you would basically, you're saying that you have an array of collection, and then you're kind of doing a similar approach to like that one of those sorting algorithms we did before, where, or insertion sort, I think, where you use a portion of the array to kind of house not the sorted values, but the actual hash values. So you'll use the left side of the array as storing the hash values. So up until a certain point of I, for an index, you'll have an assorted array of hash values, or an array of hash values, and then I plus greater than I, you'll have your normal values of the collection. In the second phase of the algorithm, we start with an empty sequence and move the boundary between the heap and the sequence from left to right, one step at a time. At step I, for I equals 1 to n, we remove the maximum element from the heap and store it at index n minus 1. In general, we say that a sorting algorithm is in place if it only uses a small amount of memory in addition to the sequence storing the objects to be stored. The variation of heap sort above qualifies as in place. Instead of transferring elements out of the sequence and then back in, we simply rearrange them. We illustrate the second phase in place heap sort in figure 9.9. So we have some array of 9, 7, 5, 2, 6, 4, where 9 is our root, 7 is our left child, 5 is our right child, 2 is the left child of 7, 6 is the right child of 7, and 4 is the left child of 5 for this binary tree, right? Now this isn't unbalanced binary tree. We don't have balance here, but So then what we do, we take the 9 and we move it to the end. Seven. Phase 2 of the in-place heap sort. The heap portion of this each sequence represents an is highlighted. The binary tree that each sequence implicitly represents is diagrammed with the most recent path down heap bubbling highlighted. Okay, so you pop the 9 off. The 7 becomes the root. The 6 shifts up. And the 4 comes over. Why doesn't the left child 2 become here? Oh, because you're going in decreasing order. All right, cool. That was section 9.4, you guys. So I wanted to get to 9.5. We have about 5 more pages here, or 4 more pages or so, until we get to the end of chapter 9. We'll get some practice with some priority queue practice problems at the end of chapter 9. So that was section 9.4 of data structures and algorithms in Python. If you guys are wanting access to the book you see on the right side of my screen or the notes you see on my left side, everything can be found in my Discord, linked below in my description. I have compiled a collection of my resources in there completely free for you guys, from PDFs of books you see to all my notes, programs, projects. They're all there for you guys to check out inside of the Discord. So feel free to join them there. What's everybody working on out there? What are we studying this evening? What's everybody got going on? Hold on, we got some chats here. Lots of chats, my bad. One day I'll learn NeoVim and be like a 1337 programmer. Vim motions is fine. Let me put on my Doc Martens. But I spend most of my time inside on IntelliJ because I'm a fan of power user. Even working on my own fork of IntelliJ as one of my own projects. Nice. What do you work on usually? Do you have a special? Unfortunately, I have my master's, but I mainly do compile design and language tool. I work on anything compiler design related, especially compiler frontend related. Hey, Magnet, welcome back. Awesome to hear from you. How you doing? Hey, what's up? Popping in for a bit while I do some last minute review for my math test. Awesome. What math class are you taking right now? We're about to dive into some math here shortly on the channel. We do need to refresh on a lot of our math, from discrete mathematics to pre-calculus into calculus and linear algebra. We stopped up to calculus 1, up through calculus 1 in college. That's all my major required for human biology and chemistry. But I did take a higher level statistics for scientists course as well, talking about alpha p-values and all those kinds of things. I don't remember a whole lot, but after we finish the Harvard CS50X course, we're going to be diving in and taking some of the some math courses. So we'll definitely need your help, Magnet, for some of those. Thanks for stopping in. Didn't see the message on automated front end and compiler, since compilation and compilers have 3 main parts / phases: the front end, middle, and back end. I do a lot of work on the front end, which typically consists of lexing, parsing, binding, type checking, doing language AST specific. Yes, yeah. Nice. Just need reading out about over compiler design, nerding out. Nice. I have a book from that same author. Yeah, this author, he's pretty. This author is good about explaining things, but it's pretty technical. Um, it's got a lot of jargon, and there are some typos I found in the book. So it's definitely not perfect, but it does do its job. I think the questions, I wish they were a little bit more coding based rather than contextual, or thinking about them. Uh, that's my only gripes, but it is a great book for concepts. Automate the boring stuff with Python. Yeah, I gotcha. Oh, this one you're talking about, the Python crash course. Yeah. Hey Rajiv, welcome. Most powerful force in human life is consistency, and I see you're doing great. Thank you so much for your support and kind words. You're awesome. Thanks for stopping in. I really, really appreciate you joining me here, and thank you for saying hello. All right, let's shift focus and code for maybe about a half hour or so on our main project, and then we'll probably call it from there, you guys, and jump back in tomorrow for some another session where we'll watch the back half of CS50 week 6 on Python. We watched the first hour today. We're gonna watch the second hour tomorrow. It's very, very easy given our current Python abilities, and so yeah. But let's go ahead and jump into the small business manager project here and just get some live coding work done here. All right, so last night I did do some offline coding on um, um, yeah, fair complaint, but algorithm data structure are more conceptual, logical, math based by nature. Yeah, it would be kind of cool. Like, what if you had the DSA book, and then like inside of the book they put like specific leet code problems for you to do? I think that would be a really good like implementation or like a style of problem like that to do. You know? Yeah, that kind of reading is just heavier and more tiring. Yeah, exactly. Like I can only read about maximum 10 pages before I start to really fade in terms of what I'm actually retaining. Just because there's so much jargon, there's so many definitions. Um, he explains things in a very technical way that if you're not kind of looking at the source code, it can kind of be difficult. And even the source code is difficult to understand as well. But we're just mainly focused on those concepts, right? We can obviously go back and solidify them, but this is just our first pass through this book, our first introduction to some of these data structures, these more advanced ones, trees, heaps, all that stuff. So we're obviously going to get more practice when we go back through and get to that practice, right? Okay, so yesterday, guys, I programmed for a good little while, or you know, did a coding session, and I added some more features here to the project. So what I did was, if you go into the business manager here, and we go into the business JSON file, as you can see on launch, you initialize your revenue, which goes into your items JSON file, determines which items are sold, takes those years, combines them into the buckets basically, and it's kind of like almost like a hash, but not really. It's similar, but yeah, we're just summing rather than creating linked lists. But our hash is that year, right? So I guess it does have some bucket properties. Um, Anywho, so we just don't have any other years besides 2025 for items or expenses or whatnot. Um, but what was happening is when I actually update an expense for a lesser amount than it already had within the system, nothing was happening to my value here. So now what I can do is if I go to expense menu, I go find edit expense, I go by number and I just select the number one expense, right? This brings up that view of the expense. Let me quickly just check on here. I want to see how we're calling the print here. I'm calling repr, which is number. But I thought that these were no longer objects. So let's go to my find edit expense. What? Expense, edit expense. So I'm just calling a print to temp expense, but I'm displaying expense formatted, which display expense formatted. Where is this? here. Why is this not in my file? Interesting. I should probably move that. Okay, so what happens now is I updated that feature. So if I go to um, business.json, right? Watch this number here. If I go amount and I increase this up to 200, right? That increases, this is, imagine there's a decimal here for the remaining cents at the end. So that increases up to from 200 to 300. But now let's say I go back down to 100. This should go back to 200 now. Boom. So now it's updating appropriately. And I posted a screenshot of the function that we did to write that in the chat yesterday in the Discord, but it's right here. So what I did was I added in a parameter of old amount given in for the expense as well, which by default is none. We pull, you know, if they provide an old amount, you'll do it, else just set the difference to the amount. So that's how we're doing that difference, right? And then we're just adding or creating the difference here rather than amount. So we need to do a similar function though for sold items and transacting sold items. So we need to do that as well. So let's go here and go def update gross revenue, annual gross revenue. So I think I have an update revenue function here, which does something similar already. So let's just do this. Let's go update annual gross revenue. So this needs to then say annual gross revenue. So we'll have to change some of those stuff as well. So let me go look up quote revenue. So here we have to go make this annual gross revenue and make all of these that. Right, okay, cool. So then in the update revenue, what we'll do is we'll pass in the optional old revenue, right? Which will be by default a none. A none. We're then going to do the same thing here and say try that except type error. So let's just do this full thing. Try item date sold there, except for that expense or item, right? Item has not sold is still available. Not sold. We'll just say not sold. Right? I'll set item here to here. And we go. If amount, raise the value error. Let's say this thing here. If old revenue diff equals amount minus old revenue, else we'll just say minus else diff. Yeah, diff equals just to amount. And then we'll just go diff here. Like so. And then we need to call, let's go here, quote, update revenue. So this is going to be update annual gross revenue. Revenue. Update revenue. Let's go quote revenue here. None. Okay, so then what about, I'm going to start up. I call, it's fine. Okay, so that should do it now. Okay, so now we need to go really quickly. We're going on the find edit item. We edit an item and we edit. So this is what I also added yesterday. So if I go back here, let me just relaunch here, run, yes. So what I also added yesterday was in the inventory, if you go to inventory menu and you search for an item and pull up the item, right? Now I have it, instead I stopped at the date created, and then I have the active status after that. Now I added in every single option that it has, and then in option 5, the user can select more options to actually get access to those other options to edit. So they can edit the name, the size, the cost, and the date created within this first menu. And then if they press 5 here, they open up another menu where they're actually able to edit, I should probably make the active status be a part of the first menu, but I guess it doesn't really matter too much. But this main menu mainly pertains to the attributes that pertain to transacting items. So if the user were to make a mistake when transacting the item, they can actually go back and pull it up in the inventory and make that appropriate edit to all of the attributes rather than just those ones required to create the initial object itself. The date created, cost, item size, name, and number. Right, so now we have the ability to override all of the attributes with an additional see more, basically, and then we can go back with 8 and go back to the inventory manager. So hold on, that shouldn't be what it's supposed to be. Edit more instead of, it should be go back, instead of inventory manager, it should be edit item, given the item, right, like that. So if we run here, yes, inventory, find edit item, item number 1. Right now, if I go more options with 5, pulls up the more options, but then if I go 8, brings us back to here. Now we can go back to inventory menu from there. So pretty cool, seamless, transition between these menus. So now what we can do is check to make sure that sold item is appropriately being reduced now when we reduce the sold price if it was an error or something. So if we go to the business JSON, we have an annual gross revenue here. If I go find edit item, item number 1, right? So this has a date sold and a sold price of $46.50. So $456. Sorry, 456. So if I go edit the cost, if I go more options, date sold, sold price with 4, update the sold price. So if I say 500 here and go back to menu, 6, that never updated. So we're not updating that there at all. So we need to do that here then. So if we call new sold item, right? New sold price equals set cost. We assign that to that value. So we'll say old sold price is equal to item quote, sold price, right? We'll do that. And then we need to pass this into there. So in business, am I calling update annual gross expenses? I'm calling amount here from there, and I'm passing in the old amount because I've already updated the expense with the new amount. Yes, so I pass in the old amount. So we're going to pass in the old amount via here. We update the item price, and now we call business dot update annual gross revenue. We'll pass in the item, right? And then we'll pass in the old sold price like that to satisfy the condition of this function, right? So we're passing in the item, which is in this case by the definition is the item, which is an object, and then the old revenue, which equals to none. So then that will do the update and then call the edit back to us. So if I go Control C here, go back here, run this, enter. So let's make sure here, let's go to our business JSON file and see what's going on under the hood. So our go to inventory, find edit item, item number 1. Okay, this pulled up this guy here, right? So we do need to deal with these conversions, right, of these values in the display. They should be showing, not the cent amount, but the dollar amounts. So this is $500, $10, or $1, $10, $1. Yeah, we're cooking right now, Nugs. We're feeling good. I was working on this pretty late last night, so it's kind of fresh on my mind. And I really gave it like a good read through. I started adding in some doc strings to my starting functions here to help get that going. So I'm going to go through before I push this and really, implement those doc strings. So when beginners and other programmers and followers to the channel read this and learn from it, that they can see exactly what I'm doing at each function call, just in my own words. So we are going through and cleaning it up a little bit, but it's definitely helps my understanding of the overall process by doing so, though. So now if we go more options with 5 and change this sold price with 4 to 600, now this should update to 600. When we call, so I want to actually, we need to go back here. We need to call and then we have to call a save file type is equal to quote business.json. Right, so now if I run here and go yes, inventory, find edit item number 1, if I go here, we go more options, sold price with 4, update sold price to 600, boom, updated to 600 right there, perfect, because we just had to call that save right there so we could visually see it. And I do want to call that save because I want to do that update right then and there, just in case if like some sort of crash happens right after they enter that new price, it saves, right? I don't want to wait for them to close this menu. Sometimes I wait for the menu to close to save all of the parameters, but I want to update this one specifically live if it is updated. So now let's try to reduce it, right? If we go sold price with 4 and call 400, yes! Cool, so it is reducing down to 400 now appropriately. So if we were to go in here, let's go, for example, let's go 8, 6, back to main menu, add item. Let's add in a few more items. Test, no, let's say this is a, like a Nike shorts, right? Cost of good, let's say this cost us $10. Size is a medium, today's date, yes, and we have one of these. Let's go add item. Let's call these Levi jeans. Cost, let's say this costs us 15. Let's say the size is extra large. Let's use today's date, and let's say we have one of these. Now let's go back to the main menu. Let's go transactions, item search. Let's go item number, let me pull up my database here. Let's pull up item number 3, which is the Levi jeans. Let's go list item as sold. Yes, sold price. We'll say this was 50. Select transportation method, delivery, boom, and then that takes us there. So now we go main menu. So we do need, the transaction manager isn't clearing appropriately. So let's go to transaction menu, transact item, business update else, clear main menu, clear terminal there. Right, I go 5, yes. Now we'll go here, go yes. Okay, now if I go back to inventory, find edit item, if I go to business JSON, as you can see, that went to 450. Why? Items sold is 400 and sold is 50. So that's doing that appropriately. Good. And then if we reduce this down, if we have more than one item, so let's go number 3. Let's go more options. Sold price. Let's make this down to, it's currently 50. Let's do it 25. Boom, that reduced it down. Woo! What do you make sure it works? What do you do to make sure it works? I just honestly, I am the tester, so I need to get better at writing tests. I don't really know how to really write like formal tests. You know, we're given like a brief introduction in with like Pi test and like with Pi test, you know, do this and you know, what was it? What is the keyword in PyTest? What is the keyword that you always say? Not append. It starts with an A though, right? It's I can't remember. Anyone knows the PyTest keyword? Um, but my methodology for how I've just been, you know, through trial and error, literally just repeating process over and over and over again, trying various different inputs. I am kind of the is there a way, is there a type of testing, you know, rather than you writing tests, is there like a way of testing that's like on like real subjects, like on like live testing? Assert equal, yeah, asserts, right? So you assert in PyTest like that this is what should be returned from functions. So is that what you're referring to? And is that like the proper way of, you know, writing tests? Because currently what I've done is just, and it's honestly helped me to become a better programmer in general, I think, because by now I'm not saying that by not writing tests I've gotten better. That's not what I'm saying, but I'm saying by not writing tests I've had to think about all the different edge cases from a user's perspective and try to incorporate this in. So like whenever I, you know, take in like input from a user, I always think about the try except for conversion to integer if I'm trying to do that, what I need to do for the different edge cases, what if they type in capitals, lowers. So I do typically try to handle those cases with, you know, method calls and things like that. I chuckle as when I think of assert, I think the more brutal one. Assert in most languages kills execution should a condition not be met. Okay. Yeah, so in the CS50P, they gave us a brief introduction to PyTest and writing tests. Um, Writing tests forces you to think about all the cases. Okay. And I think in a lot of, you know, modern companies, you're forced to write tests for things that you write, correct? Like it's standard that you have to write tests for programs that you write or for now. I wonder what it's kind of that's a whole nother rabbit hole we can dive into of what, programming is like within like a company. Like do you actually code much? Like or you mainly do like debugging mainly and fixing issues that have already been built on current products or whatnot? Yeah, Nugs, you got to stand up and stretch, my guy. If you guys are enjoying the stream so far, please leave it a thumbs up. It really it doesn't cost you anything. It doesn't really mean anything, but it really just psychologically helps me. I see those and it brightens my day and it helps me keep pushing here and coming back in. And if you guys are new here, follow along so we can connect in the future and network. I program and write code every single day, live learning through reading videos, mainly reading an actual trial and error through projects and things like that. You write tests before you write the code. Oh, okay. To make sure it passes those pre-existing tests. So you don't tailor the test to your code because that might be cherry picking. So if you write the test first, you know what you're supposed to be getting back every time. So if you don't, then right off the okay, I can see how that could work. Thousands of lines of just logging and tests. What do you mean logging? What does logging mean? Sometimes you're writing hello code, sometimes you're in meetings all day, but I'm sure it depends on the company too. Like for me, for example, like I work in a large lab. It's like the size of like two football fields. It has like huge, like a big mezzanine, like mezzanine just means like a like overarching structure where you can like, go up the stairs and get access to the portholes on these large tanks. It's kind of just like suspended in the air, so you can add stuff from these large tanks and things. But for me, I guess like a lot of my work, like I'm a manufacturing chemist, so like my job for products and like making product is to make products. So like I'm in the lab in in the testing room where the analyzers are running samples and stuff pretty much 80% of the day. Now if it's a crazy day where I have a lot of meetings, then maybe I'll have like 10% of meetings, but usually it's pretty it's very independent and very you got to make the products. Hey, Nat Neil, how's it going? Awesome for you to join me and jump back in here. I appreciate you coming in. What you working on this evening? I sure make me 10 million. Now I just got to write the code. Logging is more advanced printing. Okay. It's like at this time, this is a warning. I triggered this line with these values or the information there if there was a problem. If you log a lot, you can rewind that one. Oh, so it's just like using print values at various points to ensure like, oh, this is the log at this checkpoint. Like it's like checkpoints basically. Kind of like this is the output at this various checkpoint. I'm logging that output, and then do you have to compare those logs to the final outputs of the tests? Logs can be a structured form of debugging. Okay. I'm interested in your career. I definitely watch a video of that. I definitely watch a video of that. Not sure if you're willing as able or if this is going to be a code only channel. I'm interested in many subjects. Yeah, Richard. We're actually going to be diving into more subjects, more like math based. Now, I do think that this channel specifically will probably be tailored just to my computer science learning journey. Now I don't know if but in general, mathematics, computer science. I honestly, I don't really have too much passion to go back and learn more chemistry. I've been there and done that, and I have the job, right? So I obviously you need to keep learning and updating things, but chemistry doesn't really advance too quickly like computer science does. So it's not like I'm, you know, lagging in new material or concepts, but I guess you could also say that I kind of burnt out of the chemistry learning and stuff. I really dedicated 4 whole years of my life to grinding that as a TA, an undergraduate teaching fellow, a laboratory instructor. So I was really grinding that and but I know if people are interested, I would like to make some sort of project chemistry related somewhere down the future. Um, Now, the only thing with that though is when you're in the field of chemistry, like and building products, you're no longer like learning about all those, mathematical evaluations of like acid-base chemistry, writing out, specific chemical structures and formulas. Like I honestly haven't done that at all since college. So the main tools that I have used since graduating college with chemistry is just my lab techniques and skills, the laboratory skills. Like that was one to one. You use the same tools, pipetters, all that stuff, titrations, all use the same tools across all labs for the most part. And they obviously get more advanced. But and then the second thing that I retained most is just basic, mathematical conversions of metrics, which is like honestly one of the first things you learn in chemistry is converting metric units so you can, appropriately, do the mathematics of chemistry. And so that's honestly what the and like concentration chemistry, like dealing with like concentrations, mgs per liter, things like that, and those conversions. Therefore, I do that 99% of my day, converting those things like all the time. That math operations, that those matrix that I talk about is predicting those effective concentrations. If I have 10 different bottles of solutions, kind of like milk jugs, and I combine them all together, like I need to predict what the ratio of the concentrations of those various, factors within that solution would be. And so I have this matrix that I do that can compute that, and then I can pick and choose which bottles I want to take and then blend them together. Now, my idea is I really want to make that into a a script, a runnable script for my company. I think that would be really cool to actually have that for me. Now, the only thing I just don't know how to do is the machine learning aspect, because it has to receive back input, learn from that input, and then readjust its matrix numbers to, fine tune and tailor some more. And I don't know how to do that yet. Yeah. Am I wearing a Casio? No, it's just an Apple Watch, one of the basic ones. I do have a Casio though that I wear quite often. It's right here. I do like the Casios a lot. I like this watch a lot. Um, uh, Josh said yes. It's very detailed and organized checkpoints. Got you. I'm doing C/C plus plus. Awesome, man. What are you making right now? You working on the CS50X course? Um, Molarity galore. 6.26 times 10 to the power of 2030. Is that the, that's not Avogadro's number, is it? I think that is, or is that is that Avogadro's number, the amount of atoms in a, whatever it is? I forgot that number. I haven't used that number since college. That's like what I'm saying is you don't use a lot of these. What's cool about computer science, I think that's really interesting is now not everything really translates. I'm sure that there are some stuff, and please tell me if you guys are currently in school, but does a lot of the learning you do, like all the loops and the actual programming and the computer architecture and that stuff, does that stuff translate well to your everyday, work as a programmer, like as a software developer? Because like as a chemist, like I haven't done those acid-based maths, like mathematics, like those acid base or electron configuration. I haven't done any of that since college, and so if I were to have to like go for more advanced chemical jobs or like chemical engineering, I would have to go back and probably do some refreshing on a lot of that stuff. Fair enough. I know how that goes. So is your plan eventually switch into programming based job? I'm not sure. And I really am not trying to put too much pressure on it. I'm really just trying to see where the road takes me. I feel that if once I start adding pressure, it'll probably lessen the effect of me wanting to learn this. So, um, I'm really kind of apprehensive to put any added pressure for like finding a career or job for this. But obviously, I wouldn't be learning this if I didn't really enjoy it and have a passion for it. And so, if you have the opportunity to, fund a lifestyle from it, then that's obviously the goal. So, oh, you heard a Casio beep. Wow, you must have been paying attention real good, Nugs. That's awesome. I think Orgo gave me anger issues. Yeah, that one's pretty tricky for like the whole structuring and understanding, structuring and how electron configuration works with actual free 3D molecules can get really, difficult. And then with you also do like synthesization reactions and things like that using, solvents and be independent. Are there other people who know machine learning knowledge? Be interdependent. Are there other people who know machine learning knowledge? Yes, I was thinking about maybe like there. I wonder if there's someone at my company. Like it's a biotech company, so there's obviously got to be a computational biologist somewhere in the organization, whether in R&D or something. So I'm wondering if I can hit them up and be like, "Yo, can you work with me to write this? Like we just need to make a couple of class objects to house just these informations for like how much salt, total protein, all that stuff that it houses within this one serum, and then make all those objects and then combine them together somehow." Oh, it was Avogadro's number. Gotcha. Integrate machine learning / AI with chemistry data for your work. Yeah, I want to do that. I think that'd be a great project. We have the machine learning book back here that we'll get into eventually, but it just has a little bit more math that I'm currently comfortable with. People say algorithms don't really. It depends on what you do after. Oh, okay, gotcha. People say algorithms don't really, but I think it's still really important to know. No intention to add strain on the. Oh, no worries, Richard. No, I was just answering your question. We're all good. I appreciate that question. I really try to just convey like a fun attitude about this. I think it also just helps people, want to come join the stream. I think just uh, programming is hard enough. So if you're struggling with the attitude about it, then it's already hard enough, right? So make it easier on yourself. I make game mods, but I don't know how to add automated testing. A lot of the functionality depends on user actions and game state. Hmm. You should talk to Solakin or Script Serpent. They're making a game right now together. They met through the channel. Nug says, I remember I skipped like 6 weeks of lectures and tried learning a midterm worth of material in a weekend. I lost my mind. But that's not Orgo's fault necessarily. I hated those. It makes me want to cry. Streaming seems fun to seems fun to try to chat with randos. Yeah, it is. It's been fun, connecting and network with you guys. Really made a lot of, connections and online friends here through the group, and I really enjoy just hanging out with you guys and learning. It really helps, just not only to motivate others, but to motivate myself and keep coming back. People often ask me, what keeps you coming back, and how are you so consistent? What keeps you doing this? And it is really, the stream is a huge, huge aspect. I can honestly say if I didn't have the stream, I probably wouldn't be doing this every day. Um, definitely would probably be making excuses and being like, oh, I'll do it tomorrow, whatever. But the stream has definitely helped, though, to just propel our learning forward, though, because it's showing up every day is just one of the most, in my opinion, one of the best ways to improve quickly is just by actually showing up every day. Now, it'll get to a point where you'll start to plateau or level off with, you have to provide more and more effort as the material gets harder. But at the beginning, just showing up every day is pretty huge. Okay, so that now takes care of that. So we are appropriately now. So at this point in time, besides just some like minor bugs, like the program's pretty like solid. Like, I mean, we just need to go through and organize some of the functionality or just the structure of the functions here. Maybe put them in some separate file. I don't know, but it it's sort of doing what it's supposed to do here. Like now we can obviously come back in and add additional. So right now we have the ability to load items, convert items, load expenses, and cross-reference those two class objects to create statistics for a business. So now our next goal is to basically um, right, our next goal is to keep adding in more business statistics related to this. So we need to add in, right? So the expenses of 2025. So we could add in another, category to, house information for the by category, by method. We could house expense information to provide us information for, we need to track the shipping costs across all the items. So right now the items get a shipping cost, but that isn't being tracked anywhere, so we need to incorporate that into the annual total gross expenses. So when you add a shipping, it creates a new expense for the shipping. Basically, we need to incorporate that. So we do have a couple more features to add. Richard, I got a good 90 minutes of DSA with the stream in the background. Been a long day. I'm going to watch some Silicon Valley series before I go to sleep. Good night. Y'all see you the rest tomorrow. Yeah, no worries, man. I'm going to watch The Crown later tonight while I work on the project. I've been really big into those British old dramas. So, yeah, we just have a couple more features to add here. But at this point in time, like, do you think we should open this project up? Like, I wanted to get it myself up to a point where it had like a kind of working bone structure. And now we can kind of open this up to the public maybe and start to collaborate. Like the project itself doesn't have any, functionality that isn't above like a beginner's knowledge. It uses basic Python functionality, lists, sets, functions, file IO, but it just stacks all of them together to create this kind of elaborate project, sort of elaborate, for a beginner. And it might be good to allow the user now, other people to help, put in some of these business features. So let me know, you guys, if we're interested in, pushing this publicly as it is right now to the GitHub and then allowing for pull requests on this. So we could, allow you guys to, submit pull requests for this project, and then we can review those live on stream, and we can accept them or whatnot, merge them in. It'll help us get more familiar with Git. We've never actually done a pull request before. I've just kind of have the basics of it for actually, adding, committing, creating my own repos, both locally and remote on GitHub. But actually, the pull request and the collaboration with other users, we don't have any experience with that, and we do need to gain that. So the only thing that I'm a little bit apprehensive about is that I'm unsure, like that means that I have to have the power of accepting the the pull requests. And I myself am a beginner as well, so I'm not sure like what to be checking for against other people's code, basically. Like they submit something, how do I know that is correct? Like, yeah, I can merge it and then see what it does, but I'm a little bit worried that like my lack of knowledge. Now, obviously, we'll just get better over time, and we won't get better unless we actually start and do it. But what do you guys think? Apprehensive? Um, do you master Git? I'm not that not soon. No, not that much. Still pretty new at it. I merged my first pull request the other day. I felt like I unlocked a programmer achievement. What if they had programmer? We should do that. That'd be a cool project. Like, what if you added like Xbox Live achievements to programming? Like, you made an account, you synced your GitHub to it, you synced like your VS Code account or something, and then it automatically updates and you unlock achievements for doing certain things like write a program with 1,000 lines of code. Like you get an achievement for that'd be a cool project, honestly. Like a web app that you can log into and unlock achievements for programming or something. That'd be kind of fun. Um, if you want, I can give you a bit of help on that. Yeah, Josh, we'll definitely need a lot of help from for sure. What's a CI/CD? Yeah, I think it's best for you to focus on your own work for now. Maybe have it open for comments could be helpful. Honestly, just experiment. I need the sound effect from getting a headshot in Valorant whenever I make a good refactor. We'll have to get like a soundboard and throw that in there. That'd be fun. There's a whole thread that opens on GitHub when someone makes a pull request where they can explain the changes and if you can discuss it such before you merge. Okay. Or we could, essentially just like start a new community project. We could come up with something as a community. Me and Mahan have been kind of talking on the side about a community project and starting something and getting that going. I really would think it'd be so cool and so interactive to be, pushing and pulling stuff on GitHub live with you guys as you guys are also submitting things on the same project. And so I think that would just take it to a whole nother level. We definitely have to learn a lot more about GitHub and how to manage it if we were kind of running that show. But I definitely would need probably a few other people to kind of help take like a co-lead on it with me to help kind of guide me. Now, I obviously would want them that those co-leads to help really guide me through it to learn the process and other people as well. Um, but we obviously just need to think of a project idea if we don't want to do just this one specifically. Like if we want to just, okay, I'll focus on this one on my personal time, but then now let's go ahead and start something new from fresh, from start that we all can do together. Um, nice, that'd be fun. Also, this is a beta release. Projects like this won't be perfect. It takes time and process. Yeah, exactly. There's still a lot of bugs and functionality we still need, but it would be cool if you guys were able to, detect those bugs for me alongside me and try to push those or pull those, right? CI, continuous integration, test code automatically and rejects pull requests or pushes or more that do not pass the test. It's about writing code that manages pushes, pull requests, merges, taking, and more. CD, continuous deployment, is about automating the deployment of correct code. Okay. That seems really elaborate. Oh boy. Got a lot to learn here. Maybe one day, like on a Saturday or something, we'll have to take a 2 hour, 3 hour session and watch like a GitHub or a real Git a real good Git breakdown or like I know that there's a lot of like online like programming games that will like walk you through Git and like how to use it and stuff. So I mean I do have like a general knowledge of just those small just committing to my own repo, pushing it, using the HTTPS or the SSH key and stuff like that. So I got a little bit of praise. Hey Wasil, bro, your dedication is crazy. Thank you so much. Yeah, we're streaming every day for the past 2.5, 3 months now, but we've been programming and teaching ourselves for over 6 now. So we are really, really moving along, and every day is another data program. So thanks for coming in, Wasil. Awesome to hear from you again. Welcome back. Okay, so we need to. So then, what happens if we create an item? So when you add an item, run add item, right? If this item has a no, sorry, if you transact an item, right? If you transact an item, you give it a shipping method and a shipping price. So we need the ability, right? if the shipping method is not delivery, meaning that it is a standard or expedited shipping, we have to create an expense for that shipping. Okay, so let's call am I saving items JSON? Update gross revenue. Save file. Clear terminal. This calls, okay, this calls save file already. Down here below. Right here. So we need to say if, so if ship method equals delivery ship price equals to none, else ship price equals to this. So if it equals to delivery, ship price, else ship price is this. And so we can tuck this right here. So if it doesn't equal to delivery, we need to create an expense. Because we don't have a date though that it shipped. So should we give it the date sold? Technically, that's when the charge was made, right? When it sold. So we'll go expense. We'll add in a amount equal to ship price. So we'll have to lower this. Ship price. Oop. Oop. Right? We'll have to give this a date equal to date items sold. That'll generate the expense. And then I'll say we need to add an expense method for setting the so the expense types then are going to have to, so in business file.py we have expense categories and methods here. So a category that's going to be that needs to be hard coded in as well, no matter what, is going to be shipping. Right, so shipping is going to be a category. It's baked in. So I'll go, this is equal to shipping expense, right? I'll then save shipping expense dot not amount, cat description. Category is equal to quote shipping, right? So that'll create. So we have a amount. Call update amount on amount provided. Okay, so it has to be positive. If date, right, provide it, else use today. description, category, method, note, number. Okay, perfect. That's fine. So shipping. So then we'll make the method though, or sorry, the note shipping expense dot note is equal to quote. We'll do an F string here, and we'll insert the item that was associated with this. So shipping cost. So ship cost for item, right? So this will display the ship cost for this specific item. And so then I'm going to go here and call this dot get details. Wait, my item class have, so I have a stir, I have a repper, I have a get details. Okay, so get details. So we'll call the get details, so it represents it in a dictionary format, and then we need to convert this item, this expense, so we can save it in JSON. So we'll go shipping expense, or sorry, yeah, shipping expense is equal to shipping expense dot I guess I'll say get details again. Oh, this is expense. So my expense has a display expense, a to dict. So I have a bunch of these different methods, right? I need to go through and organize these, like to dict, get details, right? So my item class has a get details, return self.dict. So we'll just do whatever. Right, so we need to override this as the dictionary version of itself, and then we need to call here business.save business dot update gross annual expense. For the expense provided is the shipping expense. And then the old amount provided is the none. We don't have any because we're not updating here. We're just adding the current expense. So we're adding that expense. Update gross annual expenses for the shipping expense. Wasil, I've seen your Python streams. Is there a specific reason why you're teaching yourself computer science now? I love the streams, by the way, bro. Thank you so much, Wasil. Thank you so much for that positive support and comment. Yeah, I've been teaching myself Python just out of sheer will. Honestly, I just find it really fascinating. Me being a physical scientist, I have a degree in human biology and chemistry. I work as a formulation chemist for a biotech company, and I just think it's completely mind blowing that we have these physical solutions made up of rocks, dirt, types of things we've dug up from the ground, things we have synthesized in the lab, and we've somehow managed to create thin little wafers that have been able to make CPUs, that have been able to make programming language. It's just completely mind blowing. Like, really, really think about that. We went from rocks, dirt, water, solutions to thin little wafer disks, converting that into CPU cores, and then it's just so crazy that this is how even like on a more simple form of technology, like think about how a turntable works. Like the fact that we can etch grooves into a specific type of material and then play that back through some sort of amplification device, and convey that as sound, like, and interpret that as music is just insane. Like how technology works by taking these physical things we've been able to find on this planet and then completely manipulate them into brand new whole new sectors is just mind blowing. So that really is where this drive comes from. And I've just found that I've also just like the feeling of the rewarding feeling of programming and learning. I feel that I'm pretty decent at it so far. So I keep going here. So thanks so much for the comment. Hey, fake, welcome. Oh, you're saying good night. Well, good night to you. Hope you're doing well. So we update the gross expense. And then we call a save file type equal to business.json. So now if we run this program, yes, if I go to my expenses.json, if I go inventory, no, I go main menu, transactions, find search, item number 2, has no date sold, has no sold price, has no shipping method or ship price, right? So let's go convert item as sold. Use today's date, yes. Sold price, let's say that this sold for 25 bucks, right? Transportation method, let's say standard ship. Shipping price, let's say that this cost us $5 to ship. No. Oh, we're already, okay. So we're already as a dictionary here. So we don't even need to call get details. So let's go transactions, item search, number 2, list items sold, today's date, sold price 25, delivered standard shipping 5 bucks. Boom. And so then if I exit out all the way, dang it, that did not save. So we created the expense. We updated the gross annual expenses for that expense. And then so what about in my add item? My add item, I'm saving it in the database. So then this needs to be saved. Okay, so then we're saving the business file. So then we need to go here and call, but what were we doing? We wanted to save the expense within the, right, so let's go to our add expense. Let's see how we're doing this. So this is transact item. We want add expense here. We're calling all expenses stir this guy here. So let's take this guy. Oop. Go up to our transact item. Go here. Go here. Add the expense. Shipping expense dot okay, so we need to generate a number then too. So set expense number, we call new expense number. Shipping expense num is equal to set expense number, and then we'll go shipping expense dot number so my expense class I have a self dot number. So what if I say 0 here? Why doesn't that set? Oh, so we're already converting it. So let's go back, take this out of here, paste that there. Expense dot number. This is going to be we don't need this. Equals shipping expense to dict, and then we call save to file, and save file type is equal to expense.json. Okay, so now if I run, yes. Okay, let's go to our expenses file. So first, our business JSON has a expenses of $200 total. So then let's go and then our expenses JSON, we don't have a third expense in here. So let's go to transactions, item search, number 2. List item is sold. It's already sold. Line 438. 438 item D sold. Yes. Transactions, item search number 2. So we go main menu. Let me go inventory, add item, test, Cost 10, size medium. Yes, quantity 1. Okay, so let's do that. Let's go find our main menu, transactions, item search number 4. Transact item is sold. Use today's date. Yes. Sold price will be, we listed it for 10. Let's sold it for 25. Okay, here we go. So if we get this expense, we should see it go here as item expense number 3 for the ship, and we should see the expense business JSON increase up $5 from, or increase a price from here as well, from 200. So if we go standard shipping price 5. Oh, come on. So close. Line 421, I'm calling update gross annual expenses on the shipping expense. Object is not scriptable. Okay, let's just go like this. To dict. Let's remove this. And then do that. So shipping expense, quote, number. Or hold on, let's add it in. Take this. Okay, so if I go here, 1, transactions, item search number 4, this sold, yes, 25, standard, 5, okay, expenses, yes, woo, yes, we got it. Okay, so now when you load in an item and it has a shipping charge, the shipping charge gets loaded as an expense into the category of shipping. Woohoo! So now let's make sure the business JSON updated to 205. Woohoo! Yes, awesome. Nice. So then we could have a further category break this down for updating, other stuff as well. Like we could have a gross annual shipping cost, so you could keep track of the shipping cost for everything as well. Sweet. So we got that feature narrowed down. All right, you guys, I'm going to go ahead and end the stream here. We streamed for just about 3 hours. We're about a minute and a half away from 3 hours, so I will just wait until that the 3-hour mark. But we successfully were able to implement when you create an item or transact an item into sold and provide it a shipping charge, right? Or a shipping label of non-delivered, so it means it was standard or expedited shipping. where we create an expense off of that shipping charge, and then now that's being appropriately created and loaded into our expense file here. So, and then the shipping cost for item, this item here, item number 4. So ship method none. Okay, so then we'll need to put these declarations though. Need to get declared beforehand. So let's take these, remove this, right? And then put those shipping. Here, item, date sold, price sold, ship method. Then we're loading. So we're assigning those variables. Price. So we'll go here, take this. That. So now will appropriately fill in the values from the here on the item. We needed to assign the item values first and then assign the cost before assigning this note here for that item, right? The item needs to be created or updated or transacted. All right, cool, guys. I'm going to head out here. I'll talk to you guys tomorrow around 7 p.m. PST. Please message me in the Discord if you have any questions or would like to talk to me offline. I can respond to you there. Please join the Discord so we can chat offline. Please subscribe and like the channel if you guys enjoyed the time that I spend here streaming every single day. I really enjoy networking with you guys every single day. So I'll be back tomorrow like usual. Thanks so much, guys. I'll see you then.